waiting for the moon, like I wait all day for you. When I see your eyes full of stars, I know this is the best part. 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 Oh, oh, when you do to my heart. This is the best part. 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 Oh, oh, when you do to my heart. This is the best part. Hear the echoes of your voice chasing me down the hall. And you call out my name like it's a piece of art. When we're together, it's meant to be. I love the way you love me. We laugh, we smile, here we are. We know this is the best part. 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 Oh, oh, when you do to my heart. This is the best part. 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 Oh, oh, when you do to my heart. This is the best part. Waking up, sleeping in, afternoon, daydreaming with you. Spending time taking the view. I love everything we do. This is the best part. 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 Oh, oh, when you do to my heart. This is the best part. 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 This is the best part.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Good morning. I know you guys didn't fly from all the way around the world to almost nearby, close to approximately Las Vegas for that. Good morning. How was day one? Pretty good? I thought it was pretty awesome. I had a great time. It was so amazing to mix and mingle with everybody, meet so many new folks. Everybody was so great, so many great conversations throughout the day and at dinner, and I just had a great time meeting everybody. For those that don't know me very well, I'm huge on gratitude, and so I wanted to spend a couple minutes again this morning doing some gratitude stuff. So if you'll humor me, I would love to spend a couple minutes this morning on that. I know that people are still trickling in, but I would love to have our meta folks, our blue shirts, stand up, please, this morning. I can see about 3 of you in the front row. Please, let's give our meta folks who are working on React every day a round of applause. Thank you so much. Do we have any framework or library authors in the room this morning? You stand up, please. I think it is safe to say that without the framework and library authors, React would not be a quarter, a third of what it is. And so thank you so much for making the community go. Thank you for making it so much more than it is without you. There's one person in particular I want to bring up here to thank as well, and to do some more thanks. We would not be here today without this person. From the day that I started supporting the larger React org, he has been in my ear almost every day. We gotta get React Conf going again. And he has been our most tireless advocate inside Meta for the ecosystem and championing the cause of making sure that we are doing a better job showing up, supporting the ecosystem, triaging GitHub issues, doing a better job in the repos, doing a better job on communications, and so forth. It is my great pleasure to welcome to the stage Mr. Eli White.
Thanks, Seth. Putting on these conferences is really hard. There is so much that goes into them. This is my first time running a conference and helping organize. Definitely experiencing that and all of the things that go into it. It takes a village. There's tons of people involved. I want to thank some of the people that have been most involved here. And when I thank you, can you stand and make yourself known, put a hand up, something, so that people around you can celebrate you as well. I want to thank the AV team for these beautiful visuals, the stage, helping make this feel as nice as it can be. I want to thank the Westin for having us back. If the Westin could stand up, that would be great. We've had the conference here in the past, and whenever you have a conference that is welcomed back to the same venue, that's a good sign. Really nice, beautiful area. Really like being here. I want to thank Zero Slope. We've worked with Zero Slope for many years now, and we had to postpone this conference before COVID, and Zero Slope waited patiently for us to come back. I want to thank Wojtek and CallStack for helping put together the website, and Caddy and the Expo team for helping put together the mobile app. And I want to thank our sponsors, because obviously without our sponsors, we wouldn't be here today. This has historically been a Meta conference, Meta running the whole thing. But it's not about Meta. As we said yesterday, this is about the community. It's about all of you. It's about all of us coming together that help build React to put on this event for React. And so I want to thank the sponsors, especially Amazon and Remix from Shopify, to help make this opportunity for us to all be together. I also want to thank Basha Markovic, from CallStack. Basha came and found me last year at Chain React, and she said, the community needs a React Conf. We need to get back together. We need this opportunity to share and to meet. Helped us see how much the community really needed it, really lit a fire under us to get it happening again. Basha didn't just have the idea, Basha helped see us through to today. She's been here every step of the way to make sure this is possible. So thank you very much for all of that support. As well as all of the CallStack team for helping partner with us and partner with Meta to make this thing happen, both through the support of Basha as well as all of the other things that you've done with us and all of the financial support for the conference. I want to thank Matt. Matt is our only developer advocate for React at Meta. Matt has been working every step of the way with Basha to make sure that this can happen, that all of the content that you see is great, that all of the activities and all of the different pieces that seem minor here today go smoothly. I also want to thank Ricky Hanlon. If he's here, he might be sleeping. Ricky really helped make this ReactConf feel like ReactConf. He helped work with all of the content and all the different designs, a lot of the visuals that you've seen, worked with all of the speakers to give feedback, and he's written pages of feedback to help make these talks as good as they can be. He's been there to be supporting everybody who needs anything at any moment. He has spent the last couple of nights working on the keynote for yesterday, making all the slides as perfect as they can be. He's been up till like midnight, 5 a.m. yesterday, and he had all of the stress of putting together a talk with none of the glory of putting together a talk. And he did it on his birthday, which was yesterday. So thank you, Ricky, for all of that support. And of course, I want to thank all the speakers for giving the content that makes us all want to come here today, all the announcements, all of the things that we want to see and are excited to learn about. Also want to thank all of you, last but not least, the community that brings us all together. This is about you. This is about React and the ecosystem that you've all helped build. Thank you so much for being here, for being part of this, for watching on the live stream, for all of this energy that you bring to the ecosystem. Thank you again. Looking forward to today. To set up the rest of the conference, I'd like to welcome back Ash.
Thanks again. All right, I have one more piece that I want to add. There's a few folks that reached out yesterday and told me that it was their first experience at a conference. For those of you that this is the first big conference, please stand up and raise your hand. Please stand up. Please stand up. Let's all give them a huge round of applause. Stay up, stay up, stay up. One more. No, stay up. I'll also add, if this is your first React Conf, please also stand up. Wow. It's a lot of new faces. Like Dan was mentioning yesterday, I gotta sit down, thank you so much. It's the new faces that provide a special energy that helps the community thrive. And thank you so much for being there. My first React Conf was also a special occasion because of how welcoming the community was. So for those that this is your first, fifth, y'all been there since day one of React, thank you so much for making a welcoming and fun environment for those that are coming in. Yeah, huge shout out to everybody. Let's get one more round of applause. Thank you. I will also just take a brief moment to remind everyone of the code of conduct. We want to keep the vibes going. We want to make it a safe space for everyone else. So if you haven't had a chance, please review on the Discord and the posters that's around the registration office, the code of conduct. So let's get the party started. Is everyone excited for the kickoff day 2 of React Conf? Let's go. All right, now this is the energy that I'm talking about. All right, so our next speaker can run a sub 4-hour marathon. I don't know about y'all, but like, that's absolutely amazing, and it's really interesting to see how that also translates into their work within what he'll be presenting. Coming in from London and representing Italy, let's give it up for Nicola Corti.
Hello, everyone. Super excited to be here. And super excited that you actually see that you survived the party yesterday. I thought I would walk to an empty stage, but seeing you here today, it's really beautiful. So, my name is Nicola Corti. I'm an engineer on the React team. And today I'm here with Riccardo and Kari to talk about my favorite topic. You guessed it. It's React Native. Yeah, folks? Awesome. Well, in case you don't know React Native is our toolkit to bring your React code from web to native, to let you build delightful experiences. Like the React Conf app that we built to give you a glimpse of what you can do today with React Native. Go download it on the Play Store and App Store if you haven't done it yet. So we need to go back to 2015, React Conf 2015, our first open source release of React Native. But again, today I'm so excited to be here because we have so much content to share. So let me walk you through what we're going to talk about today. And we're going to talk about 3 things. First, I want to talk about the state of React Native. Then, we want to share some updates on the new capabilities that are available in the latest version of React Native. And then, we want to share some updates and tips on what we believe is the best way for you to build production-ready apps in 2024. So let's start with the state of React Native. How about we take a look at the weekly download count for the React Native NPM package? The last time we spoke at React Conf 2021, we were at 600,000. But now, I'm excited to share that we just smashed the 2 million weekly downloads for React Native. And if 2 million is not impressive enough, let's look at the yearly download count. We started small, but I'm excited to share that only in 2023, you folks downloaded React Native more than 78 million times. And I can't wait to see where you're going to bring us next. So now, it's not just about downloads, right? Our project is more active than ever. Only in the first 5 months of 2024, we shipped 19 patch releases. So back in the day, we used to ship a lot of minor releases with a lot of breaking changes. Now, we moved to a model that let us ship faster, but also ship less breaking changes. So updating React Native is not going to be a painful experience as it was back in the day. Recently, we also shipped our latest stable, React Native 0.74. And this accounts for a grand total of 30 shipped versions only in the first months of 2024. And you'll be amazed to see what's inside the latest stable of React Native 0.74. We shipped more than 1,600 commits. Those are bug fixes, new features, new capabilities, bumps of libraries, and so on. And I really want to take a moment to thank the folks in the release crew from companies such as Microsoft, Shopify, Coinbase, and Expo that help us make this release possible. But now, let's talk a bit about which companies and which partners are out there are investing hard on React Native. Well, obviously, as at Meta, we're using React Native quite aggressively in a lot of our apps, such as Facebook, Meta Quest app, and much more. But then, we also have Microsoft, one of our stronger partners. They're a leader in desktop development, with desktop applications such as Office and many more. Then, Amazon is also another key partner of ours. They've been using React Native in a lot of their mobile apps. And I'm sure you don't want to miss the talk from Chris and Anisha just after the keynote, where they will talk about how they're extending React Native beyond just mobile and desktop. But then a lot of other partners, like Shopify, Wix, and many more, I'm sure that a lot of the apps you use daily on your device are using React Native to some extent. And if you really want to learn more about which apps out there are using React Native today, you definitely don't want to miss the analysis that Evan and the folks at Expo has been doing. They've been scraping the App Store to find out how many apps are using React Native, and you will be impressed to see how many there are. But now, back to Meta for a minute. Because I personally feel that we don't spend enough time talking about how we're using React Native internally. So today I want to share some success stories of us using React and React Native. Well, as you can see today, Meta is heavily invested on the success of both React and React Native. It's like an entire org with engineers and engineering managers fully invested on the success of those frameworks. We do this because we believe in the value that it brings to both Meta and the open source ecosystem. So at Meta, we found out that we have more than 2,500 unique React Native screens across a lot of our products. And only in the Facebook app, we have more than 1,000 screens, with popular features such as dating and many more. But on the Facebook app, our biggest partner so far is definitely Marketplace. You probably know Marketplace if you ever sold or bought items on Facebook. So this page that you see on screen is the product detail page. And today, I'm excited to share that this page is visited daily over 2 billion times. 2 billion times, folks. It's billion with a B. By the time this slide is on screen, this page has been rendered over 200,000 times. We believe that this gives a sense of all the possible display configuration, network condition, device setup that React Native is exposed to. Really, this is the scale at which we are building React Native. And it's not just mobile, right? I want to show you a couple of other products that we built recently. First, this is the Meta Account Center. It's a way for you to link your Facebook, Instagram, and other accounts together. This is how we built it for web, using React. But we obviously wanted to bring the same experience also to VR. So that's how it looks like on Quest devices. Thanks to React and React Native and our infrastructure to share code, we were able to easily bring the same web experience back to native. And if you want to learn more about our infrastructure to share code between platforms, you don't want to miss the talk from my colleague Olga and Naman later today, Cross-Platform React. And as I'm talking about VR, I can't forget to mention the Quest Store, the place where you can buy new games and experiences for your Quest devices. That's how it looks like on web, built with React. And that's how it looks like on mobile, built with React Native. And again, we wanted to bring that same experience to VR users. So that's how it looks like on Quest devices. Thanks to React, our engineers can easily jump between web code bases and native code bases and share knowledge. So really, this is a testament of how Meta is investing extremely hard on the success of React Native. But it's not just Meta, right? Today, I want to briefly talk about one of our close partners that is also investing extremely hard on React Native, which is Microsoft. Microsoft is one of our key partners, and they've been helping the React Native community in a number of ways, helping us with making releases and building new tooling. But that's not just it. They've been maintaining both React Native Windows and React Native macOS. And they're heavily invested on the success of this framework. A lot of their desktop and mobile apps have been built with React Native, and they've been shipping those apps on both web, Android and iOS, and Mac and Windows. And this is just a handful of apps of how Microsoft is using React Native in production. And today, I want to give you a glimpse, one small example of how Microsoft is using React Native. Let's look at this feature. This is Microsoft Word desktop application. And the feature you're about to see, it's called Accessibility Assistant. Let's inspect your document for accessibility issues, such as low contrast or text that is hard to read. This area that you see on the right, the column over there, is entirely written in React Native. And you can see how well it blends with the rest of the desktop application. Folks at Microsoft are using React Native to either create new features like this one or modernize old features. And I want to talk also about another key feature they've been developing with React Native, which is the Windows 11 Start menu. That's the first thing you see whenever you open a Windows 11 PC. This section over here, the recommended section, is entirely written in React Native. Folks at Microsoft have been using React Native to boost the developer velocity because it's easier to onboard new engineers to desktop development with React and React Native. I think it's amazing to see, really, how Microsoft has built core functionalities for their core products, thanks to React and React Native. So obviously, knowing that both Meta, Microsoft, and other big partners are investing in React Native is a huge selling point, right? But I think there is another strong argument when you're using React Native, which is the community. When you're using React Native, you get access to AAA libraries built by our partners and community members. Let me tell you, those libraries are just awesome. Literally. I want to spotlight a couple of them because that gives you a sense of what you can build today with React Native and those libraries. The first one is React Native Reanimated. It lets you build delightful animation, which basically bring your application to life. Look how polished those animations are running, and they're running natively on device. We even added some of them inside the React Conf app for you to experience. And I want to give kudos to folks at Software Mansion, which, by the way, I believe they're here in the audience somewhere, because they've been building this amazing library that is loved by the whole React Native community. So let's give them a big round of applause. Then we have React Native Vision Camera, which lets you unleash all the power of your on-device camera. And lets you do amazing things like the one we're doing here, the image recognition, motion tracking, and applying filter at real time. Again, kudos for this one goes to Margello for building another amazing library for React Native. And then we have React Native Skia, which lets you use the full power of the Skia rendering engine and lets you build impressive experiences like the one you can see on screen. And kudos for this one goes to Shopify. And I could go on and on and on. But really, this is the beauty of the React Native ecosystem. It's the community. It's the library that are making part of it. And it's the people that are making part of it. I'm always so amazed to see how community-driven React Native is. And I personally believe we would not be where we are today without the help of all of you. So thank you very much. And now, to talk about the new capabilities that are available in the latest version of React Native, I want to invite my colleague, Riccardo, on stage.
Hi, everyone. I'm Riccardo. I'm a software engineer in the React team at Meta. And wow, it's amazing to be here, React Conf, all amazing people. I'm very excited, almost speechless, which is not great for me right now, but let's get it started. So I want to talk about new capabilities that we are pushing to the React Native core to let you bring all the features that you learned about React yesterday into your native application. And I really cannot talk about new feature without mentioning the new architecture. Let me borrow the words of my colleague, Rick Hanlon, from ReactConf 2021 to describe what the new architecture is. It is basically a rewrite of the internals of React Native to make it synchronous so that we can use concurrent feature in React Native. So let's have a look together at how a React Native application works under the hoods. So in any React Native application, we have a native layer that is used by the system to render platform-specific UI components and let your user interact with your application, and the JavaScript layer that you use to describe your UI and implement your application logic. What you want for these two layers is to communicate with each other, of course. And this is possible thanks to a component that is called the bridge. The bridge lets messages in JSON flow from one side to the other and back. But as you may guess, using JSON requires them to be serialized and deserialized. And this can take time and potentially block your UI. And of course, this is a bad thing. We don't want that. And to avoid this, we had to make React Native asynchronous. This is the old architecture. Let's have a look at how the new architecture works instead. Of course, we still have the two layers, right? We want to render components, and we need to write our logic and UI. And they have to communicate. We basically replaced the bridge with another concept, which is called JSI, or JavaScript Interface. Thanks to JSI, we don't communicate with message passaging anymore, but we use memory sharing. So the native layer and the JavaScript layer are sharing memory to communicate. This is, of course, much faster and efficient than before, and this basically let the JavaScript layer run synchronously with the native layer. So the new architecture is not just a rewrite, of course. It enables much more capabilities that you can use directly in your application. Let's start with one that I already mentioned, which is JSI. So what I'm about to show now is something that with the old architecture was not possible to implement properly. We tried a couple of times, the CPU was skyrocketing, the device was overheating, and the result was, well, not great. So have a look at this video. This is React Native Vision Camera. And I want you to focus on the fact that we are running face detection algorithm and face blurring at the same time on device, and look how it sticks, the blur sticks to the face. I mean, it's amazing. And again, thanks to Margello for developing this amazing library. It's the same that Nico showed you before, but let's focus on the blur here. The other feature that the new architecture enables are concurrent React APIs. At the end of the day, we were developing the new architecture to let you use those, right? So let's have a look at one of those examples. Use layout effect. In the old architecture, if, for example, you want to render a tooltip which is anchored to another view. The anchor in this case is the red box. We need at least 2 rendering passes. One to render the red box and get all the layout information, and the second to use those information to render the tooltip. It's not great, right? With the new architecture and concurrent React APIs, we can use the layout effect and get all this information right before the rendering phase, so we can render everything at the same time, and the result is much better and what probably you were expecting. So we first open the usage of the new architecture in React Native 0.68 a couple of years ago. At that time, it was in an experimental phase, and it was hidden behind a feature flag or an opt-in flag. We did that to let you try it out in your application and report feedbacks. And we took your feedback very seriously. One of the feedback that we received the most was that migrating to the new architecture, whether you were developing a library or you're actually up, it was taking a lot of effort and a lot of code changes. So in the next few months, we were working on basically 2 features. One is bringing back some API that you were using in the old architecture to the new architecture so that you can start adopting the new architecture without changing any line of code, and several interoperability layers to let your legacy modules and legacy components run smoothly in the new architecture, again, without changing a single line of code. And of course, we didn't stop there. We collaborated with several partners, for example, with Expo, to try out all the Expo modules in SDK 51. And thanks to that experience, we will be able to push fixes in the core so that all the Expo modules in 51 are working smoothly in the new architecture, and you don't have to change a single line of code. This work was when it went really well, and Expo is calling out instruction on the release blog on how to try the new architecture in your application and how to report things that may not be working. Expo was not the only partner we worked together with. We work with Software Mention, CallStack, and other independent maintainers to try out their libraries in the new architecture and push further fixes in core to make sure that every one of you, after React Conf, can go back home and try their application with the new architecture turned on. And that's why I'm very excited and very proud of the team today to announce that we are considering the React Native new architecture officially in beta. So, again, when you go back home and after the conference, you can spin up your application, move it to 74, and if you are using mainly Android, you can turn on the new architecture, modifying the new arc-enabled flag on the Gradle.properties file. And for iOS, you can run polystall with the RCT new arc-enabled flag set to true. If you're using Expo, migrate to SDK 51, and then you can use the Expo build properties config plugin to turn on the new architecture for both iOS and Android. For more information, this is the link with the announcement, so check it out in the working group. And now, to talk about production-ready application, back to Nico. Shit.
Thanks, Riccardo. So now we want to share some tips and suggestions on what we believe is the best way for you to build production-ready app with React Native in 2024. So I'm personally an Android engineer. I've been doing Android applications for like 10 years plus. And I know how complicated it is to build production-ready apps, 5-star apps, because our devices are changing, our users are changing, and the user requirements are changing as well. So keeping up with the reviews and the quality of the app, it's complicated. So our goal in the React and React Native team is for you to focus on building beautiful application that solves the user needs. We don't want you to spend time on fixing infrastructure issue or like dealing with tooling that is not great. So like when you open Android Studio and you do like file new project and you create an app, you have the Hello World app running out there. You feel you're an Android developer, no? Like you're ready for production. But to bring that Hello World app from the simulator to the store and let it be a 5-star app, you need a little bit of things. You will have some problems to solve, right? Let's look at them. First, you need solutions for navigation and routing and handling deep links. At the end of the day, your apps will have more than one screen, right? And you want your user to be able to navigate between them. You will need some help managing your Xcode project and Gradle file, which are notably quite hard to deal with. You will need some help publishing to the stores. For example, on the App Store, you will have to create screenshots and icons and create a bundle of your app and upload it and so on. Well, then you will have to deal a lot with dependencies and things like making sure they're up to date and they're aligned with each other so they don't clash. And a lot of other features to build, like capabilities for your app, like push notification, in-app purchases, splash screen, user authentication, and much more. The list goes on and on and on. And like, really, those problems, any mobile engineer out there will have to solve it to bring your application to 5-star, to bring it to success. And if you've been doing React Native, you probably already know a tool that solves all of those problems and many more, like Expo. So over the last months, we spent time with the rest of the team and with our partner defining what is a tool that solves all of those problems. And we call a tool that does all of this a React Native framework. We recently updated the reactnative.dev website with a recommendation on what are React Native frameworks. Oh, and by the way, we just updated also the landing page of reactnative.dev like 1 hour ago. So go and check it out because we refreshed the website and we bring it up to date with the latest standard. So if you go on the reactnative.dev website, you will find that we define a React Native framework as a toolbox with all the necessary APIs to let you build production-ready application. In a sense, this is really similar to the same concept you have on web, with web frameworks such as Next or Remix. So we're sort of bringing React Native closer to what you have on web. But now you might be wondering, OK, folks, so are you forcing us to use Expo? Are you forcing us to use a framework? Can I use React Native without a framework? The answer is yes, but from our experience, we like to say that you're either using a framework or you're building your own framework. As you're basically solving those issues that I was showing you before, over and over again. Someone already solved those issues for you, so it's pointless that you keep on solving them again. We want you to focus on building production code, on building beautiful application. So that's why, starting from React Native 075, the recommendation from the React Native team for newly created app is for you to use a React Native framework. And our framework of choice is Expo. So yes, you should be using Expo for your newly created app. We believe that Expo today is the fastest way to bring your apps from idea to production. We are obviously open to recommending other React Native framework in the future, because we also published an entire RFC on what are React Native frameworks, why we're making this change, and what are the requirements to become a new React Native framework. And now, to tell you more about what you can build with Expo today, I want to invite Kari on stage.
Thank you, Nico. Hi, everyone. I'm Kari. I'm a developer at Expo. And wow, how great is it to have a React Native keynote at ReactConf again? I feel really privileged to be here today at React's 10+1 birthday at that, to talk to you about building production-ready apps with React Native today. Now, you might have heard it said that building mobile apps is kind of hard, especially for developers coming to React Native from the web. You have higher expectations when it comes to developer experience, because you've lived it, you experienced it, you know how good it could be. And you want the same kind of experience when developing for other platforms. At Expo, we want to bring the React Native developer experience more in line with web dev. Let me show you some of the things that are tricky about native development. First, of course, we are targeting multiple native platforms in a single code base. This is what React Native is all about, allowing us to run React code on native iOS and Android platforms. Now, the really awesome thing about React Native is, of course, that React Native apps are real native apps. So when you create a text input using React Native, it's not secretly rendering it in HTML. It is using the real native text input components for each platform. This is so important for performance and the native look and feel of your app. But it does cause a difficulty for React Native developers. And this is that you need some way of surfacing all of these native functionality to the JavaScript side so you could actually use it in React. So accessing the phone camera, sending push notifications, using Face ID, all of these and more require a native module that bridges this code from the native side and makes it available to the React code. Then we have navigation. Navigation on mobile comes with a ton of nuance and functionality that you don't see on the web. Remember how React Native apps are real native apps? Well, unfortunately, this does mean that you need to also manage some of that native code. You need to keep it up to date. And finally, there is actually building your native app, both for development and deployment. Building native apps is shockingly difficult compared to web dev, and it requires specific native dev tools and a security step called build signing. React Native lets us render React code on the native iOS and Android platforms, but doesn't help with the rest. Let me show you how using a React Native framework does. I am, of course, going to talk about Expo. Expo is a free and open source framework for building universal native apps with React Native. We also built the Expo application services, which is a set of cloud services built specifically for React Native and Expo apps. It is an optional extra which you can choose to use with or without building your app with Expo. The team at Expo have been a constant presence at the React Native community from its very inception. We really believe in the technology, and it's demonstrated by our decade-long commitment to it. For example, we were the first ever to publish we published the first ever React Native community libraries, only a couple of months after the initial release of React Native. We created React Native Directory, a place for searching and discovering React Native libraries. And we helped organize React Conf back in 2016. We also contributed to React Native directly, being the first external contributors to run a release of React Native. Among other things, we helped to add async functions to React Native, and, as you heard from Ricardo earlier, collaborated with Meta to ship the new architecture to open source. And today, we are beyond excited that this has led to the creation of the first React Native framework. What React Native gives us out of the box is the ability to run React code on native iOS and Android platforms. A huge amount of work goes into making this happen. We have Metro for bundling, JSI for communicating between the native and JavaScript layers, Fabric, the native renderer, and of course, Hermes, the JavaScript runtime. And on top of this core functionality, React Native also ships with the most fundamental components, like your text, view, and text input. But the goal of React Native is not to provide access to every single native device capability out of the box. Instead, we are given the API and the mechanism to do it ourselves. And this brings us to the first hard thing about React Native development, and this is accessing these native capabilities. React Native provides the mechanism, but it does not actually expose all the functionality needed to build modern apps. Hence the reliance of community libraries. These are often from people and companies from the community who needed to use functionality from the native side didn't yet exist bindings for. Libraries for animation, maps, vision. And we have built many of these ourselves. And we pulled much of the fundamental functionality together into the Expo SDK, our extended standard library for React Native. It includes a huge amount of components and capabilities that are not included in React Native, but you usually need to build your production app. For example, the SDK includes libraries for common authentication patterns, one to facilitate browser-based OAuth flows, like login with Amazon, the all-important Apple Auth, and a library that lets you use biometrics like Face ID and fingerprint. There's Expo notifications for sending local and remote push notifications, and Expo sensors, which lets you access device sensors that measure motion, orientation, ambient light, and open the door for creating experiences like this one, a neat little game that uses your device orientation as controls. We rarely create libraries that are already included in React Native, but one exception to this is Expo Image, created mostly to provide better compatibility with other image libraries we have, and to support more image formats like SVG. But on top of supporting image formats, it also comes with easily configurable native transition animations. And you can even enable live text interaction on iOS with a single prop. So with these and other React Native modules readily available, you're likely to find an existing library that suits your needs. But if you don't, and you need to write some native code yourself, you'll probably want to use the Expo Modules API, which is built on top of the React Native JSI layer. Now, I know the idea of writing native code may seem a bit daunting if you primarily write JavaScript, and to be honest, it very much was, back when your only options were Objective-C and Java. But the Expo Modules API, in the Expo Modules API, the native code is actually written in Swift and Kotlin. So it tends to feel surprisingly approachable for TypeScript developers. To get started, you can use this npx command to create a new module. And this will create a new project with everything set up ready to be released to NPM. Or you can use the local flag, set it up to use in a private project. In the module, you'll have a place for your native Android, iOS, and web code, as well as an example app ready to set up for testing. Here is an example of a Hello World module where we call a function to receive a greeting from the native code, with implementations for web, Android, and iOS. Then in your React Native code, you can call a single function or your native module and render the platform-specific greeting for each platform. So you can use the Expo Modules API to build additional native capabilities for your own app, or join others in the community who are already using it to share open source libraries. So to access native capabilities, things not already shipped with React Native, we have the libraries in the Expo SDK, plus many community libraries which account for almost any need. And if you do need to build a new native module, you'll have the Expo Modules API. Next on our list is navigation. On the web, you might be used to building your own navigation UIs from scratch. On mobile, users have certain expectations about how the navigation should work. There's a lot of subtle behavior that makes building your own UI completely from scratch a very difficult challenge and something you're likely to get wrong. Let me show you what I mean. Here's the Conf app on Android and iOS. Has everyone downloaded it? Well, there's still time if you want to do that. We're still on day 2. So you can try it out, try some of the things I'm going to talk about out for yourself. So this app has a bottom tabs layout, a UI pattern that's very much expected on mobile. There's a subtle UX expectation, even on the bottom tabs, that you might not even realize that you and your users have. Like when I scroll down, oh, did I do that? Like when I scroll down on the home page and then tap on the home page tab bar, the screen auto-scrolls to the top. Let's look at navigation between screens. On Android, the Talk Details page slides in from the left, and to go back, we use the swipe left gesture to go back. On iOS, the screen opens in a modal with an iOS-specific animation, and we actually close the modal with a swipe down gesture. So not only are we adding gesture to the mix now, we also need to support different UX for Android and iOS. Let's look at another example. Let's use the search on the speakers page. On Android, we tap the search icon to to start typing. Whereas on iOS, we scroll down to reveal the search input. This is just some of the expected behavior from a navigation system on mobile. There's a lot of platform-specific expectation that would be pretty overwhelming if you try to build it from scratch. So really, you'd probably want to use a navigation library where all of these things are already set up. Our solution to this is Expo Router, which brings file system-based routing to React Native. I'm sure most of you are already familiar with file system-based routing, as there are several frameworks and established patterns already on the web. Let me show you how we made this work in React Native. Here we have a stack navigator with 2 screens and a button to navigate between them. With Expo Router's file system-based navigation, all of your app routes are defined in the app folder. The key to making this work on native is the layout file, which is how we organize the screens and declare how they should be rendered, as tabs, a modal, or in this case, a stack. Notice that I didn't need to list out any of the routes in a stack, and that's because this information is implicit from the file system. You only ever need to define them if you want to add additional properties such as header icons, styling, or in this case, a title for the screen. So with Expo Router, you can create truly native navigation experience for Android and iOS. Not only that, but you can also target the web. That's right, in the same code base, you can build for iOS, Android, web, and even tvOS. And this makes code sharing between all the platforms a real possibility. Furthermore, we've recently added API routes to Expo Router. For React Native, this is beyond exciting, because for the first time ever, we have an easy way to write server-side code inside our React Native code base. So for navigation, you could use Expo Router. It provides a native navigation system that works beautifully on iOS, Android, and web, and tvOS. Next up, we have the native code. I think I pressed this twice. Next up, there's the native code. Although with React Native, we're building applications primarily with JavaScript, we still need to occasionally handle some native code. There are some things that can't be done without it, even with a library, such as changing the app name and icons. And of course, we have the dreaded upgrade React Native experience. With Expo, we have a solution for this, and honestly, it eliminates at least half of what I used to find frustrating as a React Native developer. It's called Continuous Native Generation, or CNG, because who doesn't love an acronym? Let's see how it works. This is the structure of a React Native project. We have our source folder for your JavaScript code, and the iOS and Android folders for the native code for each platform. And this is another folder structure of another React Native project that uses CNG. This is also an Expo Router project, so we have our app folder for our file system-based routing, and our component folder for the rest of our components, and not a native folder in sight. And that's because this project is using CNG, Continuous Native Generation, to generate these folders. The idea behind CNG is that native code can be generated from a set of inputs, making it ephemeral. I mean, anyone here checking their node modules to Git, for safekeeping? No? Chances are you don't. Chances are you're going to install your node modules based off your package.json and your log file using npm or yarn. So in a similar way, you can run npx expo prebuild to generate the native projects based off of your app.json and package.json. Note that this is not in any way a lock-in. You can always opt out of using this workflow and manage your native folders directly. But let me show you where you might want to use CNG. Who here hasn't heard someone complain about the React Native upgrade experience? I mean, it's basically a running joke in the community at this point, and for a good reason. Recall that React Native includes all these wonderful tools that make React code work for iOS and Android. Well, all this code lives inside the iOS and Android folders. And I think you might already see the problem here. If you check these folders into Git, and then you make additional changes on top for your own project needs, it means that there is no way to automatically, reliably upgrade to a newer version of React Native. You need to do it manually. And I mean really manually. There are tools like the upgrade helper that show you the diff between your current version and the version you want to upgrade to, and you go through every single file and manually copy them into your code base. Who here has done that? Too many times. Even with the CLI tool that adds this diff automatically file by file, you're still left to oversee each merge and resolve the conflicts. Painful indeed. Compare this with how you'd upgrade a React Native project that uses CNG with a single CLI command. You install the newer version of React Native and simply regenerate your native folders with pre-build. Other than upgrades, a huge benefit of CNG is that all of your app config is defined in a single file, in your app config file. Now, I don't know about you, but the first thing I do when I start working on a new app is create the app icon. I used to do the same when I did web dev. New website, adding a favicon, top of the to-do list. It just makes the thing you're building more real and exciting. God, that's better. There, the app icon is updated. Doesn't this instantly feel so much more like a real app? And here's the change I actually made in my app.json. And here are all the changes that were generated automatically because my project is using pre-build. You can also extend pre-build with config plugins. Config plugins are basically little JavaScript functions that allow you to edit files in the native directories during pre-build. So you could write your own config plugins or use config plugins that are shipped with libraries. So for example, we used the React Native boot splash config plugin to configure the library for the Conf app splash screen. If our app didn't use CNG, we would have had to follow the instructions in the README to manually edit some of the files in the Android folder. But with CNG, we only need to add a plugin to our plugins array. So to better manage the native code in your app, you can generate it dynamically using continuous native generation, and use config plugins for any additional changes. Now, let's move on to the last and perhaps the most difficult part of native development, and that is the native builds and deployments. What do we actually need to do to get an app from your local machine to run on your phone? First, we need to have our build environment set up. That's not too dissimilar from web dev at a glance, where you need to have your node and your npm and such. But to build native apps, you also need some special tooling. So Android Studio for Android and Xcode for iOS. There is already some nuance here, such as you also need to install and set up Java for Android Studio, and Xcode, you can only get it if you have a Mac. Next, we also need to sign builds. Build signing is necessary for any native apps, and without it, your phone actually won't let you install it. So for Android builds, you need to create a key store. This is actually not too hard, and you can create one anytime on your local machine on Windows, Linux, or macOS. On iOS is where things get a bit tricky. You need a provisioning profile and a sign certificate. These are tied to your app ID and also contain information about capabilities that your app is allowed to use, so you need to keep them up to date. There's even more nuance to it, but suffice it to say, it's complicated. And this brings us, and this is exactly what we want to improve with EAS. EAS is a cloud service that helps you build, develop, and deploy React Native apps with ease. It bears repeating here that you can use the Expo open source framework without using EAS. And everything you can do with EAS, you can do without. It just might take you a little bit more work to set up and maintain. The main two things that EAS wants to achieve is to allow you to develop native apps without needing the native development environment set up. And secondly, we want to handle the hardest parts of native app development, which is the credentials management. With EAS, the builds are configured via an EAS JSON file and can be triggered via a CLI command. So by default, you have 3 build profiles with the 3 main types of apps you need to build. Let's focus on the local development build. Now, using a CI for local development might sound a bit unusual at first, but given that React Native apps, the majority of development is on the JavaScript side, it actually makes sense. Let me show you what I mean. A React Native app consists of two parts: your actual native app with the native code, and the JavaScript bundle with the React application code. In production, the JavaScript bundle is included within your native app bundle. But in development, you typically load this bundle from your local dev server, same as live reloading works on the web. So as long as you haven't changed anything on the native side of your app, this is the iOS and Android folders, you can actually keep using the same native app bundle for development. The Expo Dev Client enables just this. It's a library that adds additional developer tools to the debug build of your app. In addition to launching from your own machine or others on your network, you could open a version of your app running on a dev server on a colleague's machine on another side of the world, or even a build that's hosted on a server. Now that we have our JavaScript bundle sorted, this leaves the actual native app. You can always build this locally, but let me show you how you can do this with EAS. For my Android app, I can trigger a build using the EAS CLI. Since this is the first time I'm building the app, the CLI creates the project for me on expo.dev and asks me if I want to create a key store, the thing needed to sign the builds. Yes, please. My local code then gets uploaded to EAS, and the build kicks off. Once the build is finished, you can immediately install it on a local Android emulator or your plugged-in Android phone. The build artifacts are also stored in the cloud, so you can also install it directly from the website via QR code, which is handy for installing on devices, using Expo Orbit, which makes it easy to install it on simulators, or just download it for any other reasons. In fact, the rest of your team could use the same development build too. The iOS build is similar, only you get prompted to log in to your Apple developer account to generate the signing credentials. Recall how, during development, we use a local dev server to update the JavaScript code on the fly? Well, by a similar mechanism, you can actually update the JavaScript bundle on non-development builds as well, using EAS Update. You can create the JavaScript bundle, JavaScript Update, which will be downloaded the next time your users open their app. This can be handy for delivering small bug fixes to production, or sharing quick previews during development. On the web, we're used to doing PR previews as part of our workflow. With EAS Update, you can actually create PR preview workflow in your React Native app. Say you're working on the React Conf app and you get a feature request. Could we add a link to the Conf Discord? Sure, that's a great idea, Lauren. Let's do that. So we make the change and raise a PR. With the Expo GitHub action, we can configure the update to be created automatically on each build, and the preview link gets added to the PR automatically as soon as it's built. So we can scan the QR code to open it on your physical phone from the PR, or open it on expo.dev and install it using Expo Orbit. This was the example of opening it on a local Android emulator, and we can do the same thing for your iOS simulator. This makes PR reviews way more palatable and more in line with what we're used to on the web. So far, we've been talking about the development build. Once you're done with development, you'll want to create your production build to share with your users. A production build is actually quite different from a development build. I mean, it doesn't have the dev client for one, but it is also a much more optimized format of your app, and is not even directly installable on your phone. And it also has different signing credentials. With the default EAS config you get out of the box, the development profile is set up to create the build needed for development. And the production profile creates the production build. So really, all you need to do is pass in the production profile to trigger your production build. This build will then be available to download from expo.dev, or you can use another service, EAS Submit, to submit it via CI. With EAS Submit, you can pick a build, either from EAS or from your local machine, and submit it to the app and Play stores. This spins up the submission worker on EAS and uploads your build. So for builds, both local and production, build signing, and deployments, we have EAS. Together, these are the tools that support you in building truly production-ready apps with React Native. Yay! Thank you. So to round off, throughout this presentation, you've heard us mention this React Conf app a few times. We built it to show you an actual real-world example of putting everything abstract that I'm talking about here into practice. It shows you examples of a lot of the things that we'd commonly want to use in your app, many of which are mentioned in this talk. So we have navigation with bottom tabs and modals. We have data persistence. Have you noticed that it works offline? We have haptics, like when you bookmark an item or touch one of the tab bar items. We have animations, like the header scroll on the home page. We have light and dark mode, an animated splash screen, push notifications, an in-app web browser, and we also add some less common but perhaps interesting features, like has anyone found the secret modal? Well, one person has found it. Well, try pressing and holding on your app icon on the home screen, and on iOS, you might find a way to change your app icon. And finally, as a shout out to probably one of the most awaited releases from day one, it is, of course, using React Compiler. We've just made the repo public on GitHub from now on. So if you're curious to see how everything I talked about fits together, you can check it out. We added instructions on how to build this app on your local machine or via EIS. And now, for the wrap-up, I'll hand it back to Nico. Nico?
Thanks, Kari, for this amazing presentation of what Expo is capable of today. But now, it's time to recap what we learned. So we first talk about the state of React Native, and we talk about how Meta is using React Native and which companies are investing extremely hard on the success of this framework. Then we talked about new capabilities, such as the new architecture now being in beta. And finally, we gave suggestions for you how now you should build production-ready apps today in 2024 using a React Native framework like Expo. And with this, I want to thank you very much for listening and enjoy an amazing day 2 of React Conf.
Thank you. Oh my God. All right, that was jam-packed. Our next duo actually is the first person I want to call out is this amazing presence. Ever known this person that just whenever they enter the room, they just radiate kindness and warmth? Well, they are a hug personified. And their partner, that I'll also be collaborating with, is representing both Kenya and India. So I want to get y'all to help me give them a really, really nice, warm welcome when they get on stage. But the amazing thing about her is that she's very unexpected. She definitely caught me off guard with a lot of interesting fun facts, and I hope that this interesting combination of the duo on stage with the information that we'll be sharing with y'all really captivates y'all for what they're about to announce. I'm actually really excited myself, and man, it just keeps getting better and better and better. I didn't think after yesterday and all the talks that I'd be still excited, but just anticipating what they're about to present just has me like pretty pumped up. So, how are we doing today? How's everyone doing so far? Yay, woo, yeah, all right, we're keeping the energy going. I know there's a lot of folks going for break. We're waiting for AV to kind of get set up right quick. No pressure, you got this. But I also wanted to really also shout out those of you that are tuning in online. Thank you for tuning in the first place and following along with us right now. I'm also really curious on where you guys are tuning in from. So if you can interact and drop your flag, your or city that you're representing in the comments, that'd be very much appreciated. Yesterday I met a lot of folks that came from Brazil. So shout out to the Brazilianos. Another group from Iceland came asking for amazing hugs. I'm still offering hugs. So please do come. And as a matter of fact, there's one note I wanted to capture, if you don't mind me taking a quick look. But yeah, no, there's that. With everything set up, please give a huge welcome to Chris Tragg and Anusha Malden.
Hi, everyone. I'm Chris from the Developer Evangelism team at Amazon, and thanks so much for joining us in person. And for everyone online, hi, Mom. Quick shout out to CallStack and Meta for bringing back this event. If you've been at any of the recent React conferences over the past year, you may recognize my colleague, developer, and bouncer, Anisha.
Hey, everyone. Hey everyone, I'm Anisha, Senior Developer Advocate at Amazon, clearly the bouncer. And unfortunately, bouncer duties do come with their risk, and I've injured my neck, so please, I apologize for the stiffness. I'm not usually so stiff, so please bear with me. But let me start by asking a question. How many of you shop online? Okay, expected. So when it comes to app development, choosing between React Native and native development, I feel like it's choosing between whether to shop online or visit a physical store. Native development is like shopping in store, where you have direct access to different products and can customize every aspect of the shopping experience. However, it also means you have to invest more time and effort into navigating through multiple stores to make your purchases. On the other hand, React Native is like shopping online through a global marketplace. I think we know what we're talking about. You can quickly browse multiple products, add to your cart, and have them delivered straight to your door. And if you're like me, that means a standing order of about 12 paper towel rolls per month. Similarly, React Native allows you to write your code once and deploy it to multiple stores, saving you time and effort. And as we just saw from Nico, many of our product teams at Amazon have embraced React Native for this exact reason, building iOS and Android apps for the same reasons that customers buy online: flexibility, scale, and customization.
So as you may recall from the tagline on React Native's docs, it's learn once, write anywhere. And for any of you Amazon customers in the room, a common catchphrase you might see on some of our packaging and products is, for streaming, is watch anywhere. And so our goal is to show you how React Native enables you to learn once, write anywhere, watch anywhere. So in other words, let's talk about how to extend your apps beyond mobile and desktop, why we're using React Native at Amazon, and which libraries are great for building apps across smart TVs, automotive, tablets, and a ton of other devices you likely use but have not considered it as an option to build for. As you can imagine, there's a handful of key factors to keep in mind for multi-device experiences. And that, my new React Conf friends, is where Anisha's going to dive in.
Thanks, Chris. So I'll be sharing the considerations for watching everywhere, or in the correct technical lingo, for scaling your app to multiple devices and form factors. Now, if you aren't already specifically working on a multi-device project and are thinking this is a good time to take a nap, just hold that thought, please. These considerations are just as relevant to your user's app experience. We're talking about performance, handling various user and device interactions, scalability. So, by learning how to make your app, extend your app beyond mobile and desktop, you're also learning how to make it a best-in-class experience for your users.
So let's start with the obvious question. Why Amazon and React Native? Totally fair point. The truth is Amazon's been using and been building with React Native for years. So recently, Anisha and I had the opportunity to add a handful of apps to the React Native.dev showcase, including our main shopping app, Alexa for iOS and Android, Amazon Photos, Kindle itself uses React Native, and the Amazon App Store. I should also note that Amazon Music is also powered by React Native as well. As Anisha hinted a moment ago, these teams are using React and React Native for some of the main reasons that you chose to join us here today. So first off, it's faster development and it's simply cost efficient. Frugality is really important to us so that we can keep our customers' costs low. As you've likely experienced, a unified team can deliver more builds quickly. There's a strong third-party ecosystem, a lot of you in the room, for libraries and dev tools. These are benefits I don't need to explain to this room. And also just delivering a consistent user experience while allowing custom native functionality. And so, but mainly, we have a lot of devices. And with React Native, we're able to reach a balance between code reusability and the reality of customizing for native functionality. And so, quick show of hands. I actually can't really see anyone. Here we go. Quick show of hands. How many of you have ever owned or own an Amazon Fire tablet? Okay, keep your hand up. What about a Fire TV? Okay, how about like a Fire streaming stick? And what about an Amazon Echo or Alexa device? Okay, for all of you with raised hands, Anisha and I thank you for your business. Start hucking out sticks here. If you're not familiar with Amazon's devices, it includes our collection of smart TVs, streaming media players, tablets, actually in-car entertainment systems. We launched our first Fire TV stick 9 years ago, built on our implementation of the Android open source project. We call this Fire OS. Existing apps built for Android with Java, Kotlin, React Native, Flutter, and other cross-platform frameworks can be ported, sorry Flutter, tough week, can be ported for publishing to both Google Play and Amazon App Store. So if you check out our docs and our SDKs, you'll see a majority of our efforts are to make it easier to help you build across multiple digital stores. Today, there's hundreds of thousands of developers building apps for Amazon devices, and we actually now have over 200 million Fire TVs around the world. So we believe that building with React Native allows our teams and you to build apps for multiple devices that feel native to the hardware that they're running on while maximizing developer productivity. Coincidentally, a few years after we launched our first Fire TV stick, so I guess 7 years ago, React Native Core started to add support for TVs. So hallelujah. Support for Apple TV was introduced in 0.49. So that 2017, that was 7 years ago. We're getting old, Anisha.
Tell me about it.
And in the following year, pull requests for Android TV were merged starting in 0.55. So this was just the beginning of better TV support for app developers. In fact, since 0.62, all these TV efforts have been forked into one of the most popular TV libraries today, React Native tvOS. I'll note it's a little confusing that this package actually works both for Apple tvOS and Android and Fire OS. This is a fork of React Native. It's kept up to date with Core along with essential TV-specific features like better focus management and access to touchable controls with TV remote support. And we have to give credit where credit's due. We are here at React Conf today because of legends such as the entire Expo team, Doug Lauder, David Vaca, Yusuf Yildirim, and many, many others that have been working tirelessly to make React Native an excellent solution for building TV apps. While these community efforts for better TV support are remarkable, there's plenty of pain points to solve for when building for multi-device experiences. In fact, there was a recent episode of the React Native Show. It's great. Subscribe. Check it out. Where Lukash.
Wait, sorry, Chris. Hold on. We've got a celebrity in the crowd.
We have a Lukash in the room. Okay. Hey. He does autographs. So yeah, I was watching a recent episode for Building for TV, and he lays out this perfect quote to describe what we're up against when building for TVs. So he says, the streaming media market is very fragmented. It's like a very honest quote. Nothing like we see in web, Android, and iOS. In order to build applications in a purely native way, you need at least 5 to 10 different teams capable of building apps for Tizen natively, WebOS for LG natively, Apple and Swift natively, Android, Roku, and so forth. And so when it comes to this fragmentation, of course, React Native comes to the rescue. And I feel that quote very strongly. The point is, if you're building web apps, so for the React crowd here, we're mega jealous. Because whatever your app does, it not only has the power of a desktop computer, but is able to harness the magic of server-side rendering that we've already heard so much about today and yesterday. And don't get me started with the mobile app devs in the room. So iOS and Android represent 95% of the total mobile OS market share and are effectively tiny supercomputers running your apps. So I'm curious, how many of you are already building apps for smart TVs and related devices? Okay, I'm sure those, like, handful of people can agree. It is really hard, or in the least, it has its challenges. Sometimes it might feel like you're being strapped to a rocket ship on wheels, driving over 230 miles an hour. That's 140 degrees inside, so that's 60 degrees Celsius.
Sorry, guys, it's the better measurement system, the British one.
Right, hoping for ridiculous amounts of funding and an Eng team that has to complete patch updates in 3.2 seconds. So for us, this definitely is this Formula One or is it startup life? And funny enough, there's some rather interesting parallels between the world of F1 race car building and the realm of developing multi-device apps. If any of you tuned into CallStack's React Native EU conference last year, you might recognize this absolute boss of a technical leader. Anisha, tell us who we're talking about.
It's my favorite person, Gunther Steiner, and I was really lucky to meet him at CallStack's conference. For those of you who don't know, Gunther is an ex-F1 team principal. And so you might be thinking, while you might feel like the driver, consider him your typical overpaid yet overworked engineering manager like Chris over here. So what would a React Native developer like myself have in common with him, other than obviously a background in mechanical engineering and a great sense of humor? We're both working with budget limitations that require thinking through resource allocations. For him, it's spending caps to avoid race fines. For me, it's thinking about how to maximize my code reusability and maintainability to ensure my apps can run on everything from smart TVs to smart cars. Fortunately, not yet F1 cars. That would be a bit dangerous. But we both work in domains that require continuously optimizing our performance. For him, it's every millisecond of the race clock and reducing drag. And for me, it's every percentage of CPU to ensure my apps don't lag. We're building products that adapt to changing conditions, him with racetracks and mine with diverse user interactions and device-specific APIs. And in terms of keeping it real, he once dropped over 0.26 F-bombs per minute on Netflix's Drive to Survive. And that's about half my rate when I'm trying to navigate through dependency hell while I'm trying to upgrade my NPM packages.
This is true.
Sorry, Chris.
I'm a witness.
So, at a high level, these are the three main factors we need to consider when building apps for multiple devices: code reusability, user and device interactions, and performance. So let's first start with code reusability. And why? Because reusability equals to scalability. When thinking about code reusability within our app's architecture, ask yourself, what can and should I be reusing across each OS and device form factor? First, let's have a look at a typical app stack. We've got our business logic, things like APIs, config, custom hooks. And in my opinion, and in fact a lot of people might agree, people put them in separate packages. And I don't want to get started on the mono versus multi-repo war, but these things are still quite reusable across the stack. Next, we've got app state. So as you might have noticed, all the state management libraries can be used in React Native and React in the same way. And so I believe app state is very reusable across the board as well. Then we've got navigation logic. And this is where things might need to be customized a little bit. Navigation logic can be similar across form factors, but the implementation details may vary slightly depending on what device type you're using. In mobile apps, it's typical to have a stack navigation, whereas in web apps, you're used to the URL navigation. So this is where we might have to customize things. And next, when we have the UI, we've got three parts of it. The design tokens, which since they're mainly variables, are very reusable. We've got components that might vary on a case-to-case basis, which we'll have a look at in a few slides. And we've got our layout, which is probably the one thing that you will have to make sure is customized for each form factor. But what's really great is that the technology for universal apps, which are cross-platform React and React Native apps, using the React Native for Web package, provide a great foundation for code sharing. Let's look at an example. Here's Zigo. It's a package that lets you implement native menus. And as you can see, with the same code base, you get that same native look and feel on both web and native. Features such as navigation and UI components are exactly where the React Native community libraries are leading the way to help close that gap between web and mobile development. We saw libraries like Expo Router yesterday from Evan's talk, and Solido, and these libraries for navigation are significantly helpful when you're building that shared navigation structure across devices. They offer that common API that helps you define routes and handle navigation logics while customizing under the hood for each form factor. Similarly, UI libraries like Tamagui and GlueStack offer a wide range of pre-built components that can also easily be customized for different platforms. Thanks to libraries like these, the primary consideration when building multi-device apps is implementing custom layouts. Though we'll soon see it's not the only one, but a lot of the work has been done for us, and we're really grateful. Hence, by leveraging the magic and power of the React Native third-party ecosystem, we can create apps that provide a native feeling experience across multiple form factors, while maximizing code sharing. However, while this is great for most form factors, we know there are challenges and room for improvement in this space when it comes to TV, and we are actively working to address them, as well as looking to you guys, the community. Later, make sure to check out Olga and Naman's talk on cross-platform React. It's at 4 o'clock, where they'll cover how their teams are working together to bring the UI stacks together.
So now we've seen what's reusable, but let's talk about device-specific customizations. With a broad selection of device form factors and capabilities, you need to anticipate how your users will interact with your app and how to make sure that they're having an ideal user experience. For example, user inputs, navigation, and focus management for TVs are just built different. Why is this such a streaming media-specific issue? For starters, take your favorite apps you like to watch on mobile phones, and what you'll notice, sorry for the blurriness, trying to keep our copyright lawyers happy, is the obvious. So pretend those are the apps you love. Didn't do a good job blurring. The obvious thing is everything is so tappable. However, when building for TV apps, there's two main inputs you have to consider. So one is built-in voice search, right? So for us, it would be Alexa voice search. Most TV providers have some type of search solution. And the other one is I feel like a car salesman here, is your standard TV remote control. Up, down, left, right, select. It's sometimes called a D-pad. These are very different input options than tapping, keyboard, mouse. Then you need to account for them in order to build beyond web and mobile apps. React Native's docs do a great job walking through touchable mix-ins, pressable controls, and how to set up key TV remote events. Here's an example of implementing the TV event handler that allows your app to handle remote control events, and listen to them. Within streaming apps, it's not just user input, but it's think of how you, when you're watching TV at home on a larger screen, how you navigate. You'll likely notice that most TV apps are primarily a two-dimensional grid experience, often known as spatial navigation. If I was to oversimplify the basics of a TV app in my substandard sketch here, it would be a home screen, a list view, and a detail view. Besides that, it's most often just simply full-screen media playback. And so let's have a look at a typical smart TV app experience. Shout out to the team back home. Everything you see here is AI generated or they designed themselves. So again, keeping the lawyers happy. Have you ever thought much about that logo that shows up when you open a TV app? Usually it's like the app's logo, like ta-dun. That's loading in resources, assets before the UI shows up. And then you have your typical navigation drawer. And what we're looking at is what we refer to as spatial navigation. When we eventually get to a detail page, then you'll usually see some recommended videos and some options, perhaps buying, purchasing. It's my favorite show. This is a tearjerker here. And yeah, I guess this is my other, let's go LARPing. Okay, notice with every action and corresponding key event, I'm changing what's in focus with that remote control. So how is this handled? So focus management is a common challenge that many first-time React Native developers struggle with when building for TV apps. Think of some of the common questions we're stuck with, right? So where should active focus be at any given time? Where should focus transfer to following a remote control key press? Should we allow for more than just the remote control as inputs? Yes. Thankfully, there's a few common ways to address this. In React Native tvOS, the project I mentioned earlier, let's look at one of the common components, TV Focus Guide View, and how it works. So this component allows for focusable controls that can be navigated to even when they're not directly in line with other cards. So very commonly going from the top navigation over to the next card or going through another row. It also helps you manage focus between TV UI elements and navigating past it's not a scientific word, gaps, where there's just simply empty space or regions where focus could get lost. It gets more complicated when you think of all the different TV size resolutions and dimensions, and those things can resize on screen, and you've got to think about the logic. It's not as simply as marking to different quadrants and pixels.
So we've seen how to handle user customizations, but what about those native device customizations? At Amazon, we do have our own APIs for things like in-app purchasing, advertising, voice search, and more. And while you might be thinking, OK, great, another device customization I have to handle, my team's going to be so happy. The good news is there are already React Native community libraries that support not only iOS and Android, but our Amazon APIs too. A great example being the React Native IAP package. And to reiterate, this is the real point. We want to support more projects like these to help bridge that gap and make multi-device and multi-platform development easier. However, if you do want to make those native customizations, we recommend using Turbo modules. These next iteration of native modules that we heard about allow for faster app startup by bypassing that JS bridge, allowing you to directly communicate with the native code, reducing the overhead between JS and native code. Which brings us to our last consideration for multi-device development, performance optimization. Consider the processing power of a Mac M2 or a new iPad versus a streaming media player. It doesn't compare. Therefore, performance optimizations are essential, since any perception of UI delays can lead to user churn. A great example is another community package, React TV Space Navigation, from the team at Theodore and BAM. And if Pierre and Mo are watching here, some of you might be familiar with the performance limitations that arise from the default flat list option in React Native. But with flash list as an option, why was there a need for a third solution? The BAM team knew that when building for TV devices, optimizing list and carousel performance was critical and can have an even more noticeable effect on the user experience. The outcome was this project that allows us to optimize TV app performance even further with custom list implementations specifically for spatial navigation on TV that Chris showed us earlier. Let's have a look at their example. First, we have a simple component that uses their focusable view plugged into their scroll view, which then forms the raw layout that we typically see on TV. These sideways scrolling lists of content are then included on a screen that has a vertical navigation scroll view, which is all then wrapped up into the root component that contains all the spatial navigation nodes. It's not that dissimilar to what you might see from a typical list, as you can see.
Unfortunately, Hopix is not a real streaming station either. Sorry.
No. Running this example, you can see projects' use of virtualized spatial lists outperforms flat lists on every metric, notably requiring 32% less CPU power, which is amazing. You can read more about this article on rntv.dev, a blog maintained by the team at BAM and ourselves dedicated to React Native on TV. What about at a high level? Right? When it comes to performance optimizations, our host, Colsex, wrote the book, which they're actually giving out for free outside, so grab yourself a copy. Make sure Lucas autographs it. You can sell it later. However, since the guide is primarily focused on React Native for mobile development, let's examine those main principles and apply it to our goal of building beyond mobile. First is understanding the React Native implementation details and learning how to maximize them. This is a topic I'm personally very passionate about. And in my latest article, I walk through the evolution of React and how it created these two generations of React, which caused these unintended consequences of not understanding details that can lead to unnecessary UI re-rendering, which majorly affects performance.
All right, I'll admit, during the last sprint planning, when I saw a scope ticket for a love letter to React Native developers, I had my doubts, but definitely check it out. It's really good.
So what does this mean when it comes to building beyond mobile? Let's consider an example. Last month, when building the Fire TV demo app, I had to carefully evaluate my state management options. I wasn't just procrastinating. This decision was crucial for not only minimizing potential re-renders, but also due to other factors that come into play when it comes to multi-device development. When making choices for multi-device apps, it's even more essential to think twice before selecting a library. Because when it comes to lower-powered devices like Fire TV Sticks, there are other considerations like library package size, memory usage, CPU utilization, which can have a really big impact on the app's bundle size, initial load time. Additionally, having an accessible and reliable, consistent developer tools across the array of devices that we have to adapt for will leave you and myself less likely to throw my laptop out the window. Another way to improve performance is by activating the latest features of React Native, like the new architecture. The new architecture, as we heard, for React Native supports concurrent rendering and features that were shipped in React 18, which means now you can use features like suspense for data fetching, transitions, and the other React APIs in React Native, which I just think is amazing. So why does this matter again in the context of building beyond mobile? Well, I'll go back to my example of state management libraries. Libraries like Jotai, Vautier, Recoil, they all were designed with concurrent rendering in mind, and they already leverage React Suspense. So they are, right now, well positioned to take advantage of the performance improvements offered by the new architecture. And this was a key factor, again, for making that choice of what library to use for TV. Finally, the last factor to consider is enhancing the stability of apps through adequate testing and CI/CD. And in the context of multi-devices, this is particularly important when developing for TV, as the unique characteristics of these devices introduce additional challenges, like testing for various input methods. When it comes to testing for TV, choosing what to test is crucial. Developer tools like Appium for automation, Flashlight for performance, Charles for network proxying are all available right now to build apps for Fire devices. Make sure you prioritize testing scenarios that cover the most critical aspects of the user experience that we spoke about, like navigation, user input handling, and performance. And to help you, Amazon also offers dev tooling such as Systems X-Ray, Live App Tester, and IAP mock flows to help you with launching your TV apps. So, to wrap up, whether you're building for multiple devices or not, make sure you consider these three factors: performance, scalability, and handling those various user and device interactions. But if you are building for multiple devices, using React Native will have you feeling like the F1 driver, accelerating your development. I know that's cheesy, just bear with me. And when it comes to anything, any sport, any community, what is a community without its fans? And while it's obvious Chris and I are diehard F1 fans, I literally was fangirling over Gunther. You can ask the Coast folks. We are equally as excited about the React Native community. Since React and React Native are community first by design, we know it's on us to both contribute to these projects and to better support you guys, the developers, who are considering publishing your apps to Amazon devices.
And to that end, I want to share 3 ways we'd love to help today. So first, we invite you to publish React Native apps on the Amazon App Store for Fire TVs, tablets, Echo Shows across the global world of our Amazon customers. Myself and our whole team are here to guide you. Either way, swing by our dev lounge for some folks. We got a lot of socks. I can't bring these all home. These are spatial themed. See what I did there? Theme socks. Please come by. We'd love to meet you and just take our swag. We also know that launching apps require a sizable investment in your backend infrastructure and dev work. So to better support developers new to Amazon devices, we launched a program that provides 10% of your App Store revenue back to you in the form of AWS credits. In addition to app building, we know it's a lot of work for third-party libraries, both maintainers and contributors, to even know upfront if their open source project works out of the box. So we're offering up a new set of office hours dedicated to libraries where we'll help you test and confirm what's required to support Amazon devices. And in addition, we're very excited to launch our first open source funding specifically for React Native community libraries. If you're interested in launching apps on Amazon devices, we'd love to support you and help you go live. So scan our QR code. Scan our QR code and let us know. In addition, if you maintain a React Native library or our a frequent contributor project that you're passionate about, we're excited to learn about your project as we're evaluating more ways to support you through open source sponsorship. I think in the form, there's a little conditional where you can check if you're React Native library, and we love to actually know your GitHub or NPM package. Either way, make sure to answer the drop-down, and we're excited to get to know you.
If you aren't already, you can follow us on our socials, or you can check out some of the other content that we've created that we've mentioned throughout this talk and more. But if you have any questions, you want to follow up, we'll be hanging out outside in the main hall. Thank you so much. Thank you to the community. We can't wait to support you.
Thanks, all.
Awesome. Great, man. Great. Oh, thank you. Got myself a nice pair of socks. I'm actually a huge fan of socks. I have like 1 million that I've collected from hackathons. But with that, we're at the end of our first leg. We're going to take a quick 30-minute recess. We'll be back here at 11:05 PST. Rest up, refresh, and I'll see y'all again.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building. Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun. Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Come on. Come on. Let's clap with me. Keep it going, TJ. All right. Let's get it back on the tracks. So we're gonna have a dope tag team coming on. So double representation for Asian Heritage Month. So every day of the month is Asian Heritage Day. So I'm gonna need y'all to help me out and give them double the hype and warm and welcome when they get on stage. So we're gonna give it up with our first speaker, which is gonna be Satya Gunasekara, a nice, warm, playful gentleman that will take the vibe away. Let's give him a warm welcome.
Thanks, Ashley. All right. Hey, everyone. I'm Satya. Today, Mofe and I are going to talk about the internals of the React compiler. You don't necessarily need to understand the compiler to use it, but we think it might be useful to build an intuition of how the compiler works. So React was the first to popularize the declarative approach of writing UI code. At its core, React's all about the idea that your UI is just a reflection of application state. Right? Like, we know that React represents your UI as a tree. The tree is composed of nodes, each of which represents a component. When state or context changes, React needs to recompute the UI. React re-renders the component and all its child components to recompute the new UI. When your component is re-rendered, every single value in your component is recomputed, even if it doesn't depend on the state or context that changed. You could say that React is like too reactive even. So imagine if we could only recompute values or components that did actually change. And what if we could do that automatically? Well, we showed React compiler yesterday, and that's exactly what it does. But how does the compiler actually understand your components? Before I joined the React team, I worked on V8, which is the JavaScript compiler in Chrome. V8 would model the JavaScript specification to understand how to optimize your code. And similar to that, the React compiler uses the rules of React to optimize your code. The rules of React primarily exist to help you build complex UIs without bugs. The compiler being able to use it is just a bonus. The rules of React are probably familiar to most of you, but it's OK if you don't follow these today. For the most part, the compiler will detect if you violate these and skip compiling those components. Let's go over a few to understand what they are. We're all familiar with this rule. Components and hooks must be pure. Strict mode already helps you catch violations of this type of bugs. In this example, the hook isn't idempotent. The return value could change between calls without React knowing about it. Instead, you should use the useSyncExternalStore hook to let React know when the value changes, so React can re-render your component. Now, in this example, the component is reading and writing from a guest variable that was declared outside it. Similar to the previous example, calling the component multiple times will produce different JSX. And what's more, if other components read this guest variable, they will produce different JSX too, depending on when they were rendered. That's simply not predictable behavior. Instead, you can fix this by passing guest as a prop instead. Now your component is pure, as the JSX only depends on the guest prop. Now consider this example, where we modify the item prop directly to add a new URL property. This breaks encapsulation, right? Now, if the parent component sent the same item to some other child component, the child component is going to get the surprise URL property, whether it wanted it or not. Instead, always create a new local variable and modify them. Once values are passed to a hook, you shouldn't modify them. Like props in JSX, values become immutable when passed to a hook. One important principle in React is local reasoning, the ability to understand what a component or hook does by looking at its code in isolation. So hooks should be treated like black boxes when they are called. Like in the previous example, always create a new local variable and modify them. When you use JSX in an expression, React may eagerly evaluate the JSX before the component finishes. This means mutating the values after they're passed to the JSX can lead to outdated UIs, as React won't know to update the component's output. So don't mutate values after they're being passed to JSX. Move the mutation above the JSX, or just create a new value. So those were some of the rules of React. Like I said, the rules exist to help you build complex UIs. We're not adding new constraints just for the compiler. It's for building UIs. But they also help to carve out like a safe space for the compiler to optimize your code. These rules are what makes the React compiler possible. Now we've learned about what information the compiler can use to optimize. But how does the compiler actually work internally? I'd like to invite Mofe on stage to talk about how the compiler works.
Hello? Oh, hey y'all. So Satya just explained how the rules of React help humans write more maintainable code. The same rules, well, more generally, the way that we write React code is also very useful for tools like React Compiler, ones that analyze and optimize your code. So for the rest of this talk, we're going to talk about some compiler internals. And what's a better way to do that than write one ourselves? So 20 minutes is not a whole lot of time. So just to be clear, we're not writing all of the compiler. The one that we write should be able to handle very basic JavaScript, basically making objects, accessing fields, calling functions, and returning stuff. And it should do one thing, add memoization code so that we don't need to. So if we do this right, at the end of the talk, we'll be able to take components that look like this, ones that we write, run some build and compile command to generate a memoized version. So the compiled result should have used memos, like on the right. And just to clarify, the real compiler does not add use memos, but just for readability. It's much easier to read this. OK, so let's get started with the demo. Click a button. Cool. OK, so this is my coding setup. On the left, I have the compiler, which we need to write, all of it. And on the right, I have a terminal program that will need to run our compiler as we're writing it. It's useful for seeing stuff like console logs. So if I console log here, it's going to show up on the right. As you can see, there's another file here called input.js. And this is the input to our compiler. So whatever I type into this file, that's going to get run on the right. So if I type hello, it shows up. As you can see, we're not transforming anything right now. The output is exactly the same as the input. So I'm going to paste in a tiny React component that will let us test our compiler as we're writing it. It looks really small, but I promise it's more than enough for us to work with. And now we can get to coding. So we're going to use a popular library called Babel to parse our JavaScript input. And the way to use Babel is you pass in functions to this visitor field. And I'm going to write a callback for function declarations. So Babel should call this every time it sees a function in its input. So if I print the function name in here, I should see found music player on the top. Okay, so this does get called by the feed function and, sorry, music player function. Our next step is to take the information Babel passes to us and turn it into a representation that's easier for us to work with. So I'm going to call a function called read instructions, give the Babel function to it, and store it in a instruction variable called instructions. And let's just see what this instructions looks like. Okay, it's just a collection of instructions. And hang on, I can actually print them out. If we look at the printed logs, the first thing to notice is that each instruction produces a value. So we're printing out a special name for this instruction value, the $0. But in our code, it's just represented as a number, the ID of the instruction. Some types of instructions might have operands. Like, for example, instructions 0 and 1 are parameters, and their operands are string names. If I keep on going, the next instruction is songs, which is a property read off of an object, and its operands are the number 0 as well as the result of instruction 1, the parameter songs. Okay, so also one more thing to notice is that one normal line of code might map to many instructions. So just so we get all of them, this really low-level flat representation makes it really easy for us to trace through how data flows through a component. It also lets us apply memoization at the instruction level, which means that our generated use memos can be pretty granular. All right, so let's get back to writing our compiler. We don't have anything yet. So in order to actually transform our input code, we're going to replace the input code's function body. And I'm going to take the body, and if I pass in an empty array here, we'll see that the output on the right gets no instructions in its body, not quite what we want. We're going to use a helper function called CodeGen.js to synthesize a new function body for us off of those low-level instructions we just saw. And we are going to use the result to replace the original function body. So our generated output looks pretty exactly the same as the input, except for missing a comment. We don't represent comments in the low-level instructions, so that didn't make it. And now we're finally done with writing all the setup. So far, we've converted our JavaScript input into a very low-level representation here. And we've managed to generate the output from scratch using this representation. And we can finally get to the fun stuff, the part of the demo where we start generating these memos. So we're going to start by defining a function. It's called analyze. It takes in the set of instructions as a parameter and returns a set of values describing those instructions. A set of information describing those instructions. And what should we do inside of analyze? Well, we want use memos, right? Maybe we should just tell CodeGen to memoize something. Well, I don't really know what to do. So as a start, maybe every instruction should be memoized. We need to call it. Analyze. Going to call analyze instructions and pass what analyze returns to CodeGen. So this is how we're consuming the information. And now we see some pretty crazy looking output here, right? Hopefully React compiler doesn't actually do this. It's a lot of use memo calls. We're going to talk about that, but before that, I noticed something else really interesting in the output. There's just 2 lines of code in the input we gave our compiler, but it was able to split up all of those into separate use memo calls. So we have 2 lines of input and like, I don't know, 10 use memo calls. The reason for this is because of our low-level representation. So we see that every instruction can correlate to a use memo. All right, so let's go back and figure out why we have a billion memo calls. Well, here I print the result that function returns, so maybe you can take a look at those. Okay, so we're memoizing everything. Why do we? That's right. we're memoizing everything. So maybe we can take a look at the instructions and figure out which ones actually need to be memoized. So maybe we don't need to memorize songs at index 0, for example. If I'm reading a property off of an existing object, that's not going to create a new object or a new function. Similarly, reading description shouldn't need that. And we can also walk through this representation. So params, read properties, declarations, load constants. But call, that one. If I'm calling out to another function, that function might create and allocate a new object to return. So call instructions are something that we do want to memorize. So, okay, maybe we should look at the instruction kind to tell us. And call instructions should be memoized because just like we said, it might create a new object to return, but if we also create a new object directly, that should be memoized. And now our output looks a lot more reasonable, right? But it still doesn't look quite right. Oh yeah, we're missing the dependency arrays. Well, what should we do here? How do we fill in those dependency arrays? Well, maybe we can take a look at the low-level representation to give us a hint. So we skip to the call instruction, which is what we're actually memoizing. And I see that the call instruction uses two other instructions. This thing called 5, which is this global variable array that we're reading, as well as the parameters songs 1. Okay, so maybe my dependencies are just the results of other instructions that I use. Every value that I use, maybe I should just add that to the dependencies. And pass down dependencies. There we go. How does that look? Any issues? Just a couple of issues, so you might be a little confused which one we're going to talk about. So yeah, it's the dependencies array, and that's what we're talking about. It's not quite right. Why is the global array object in there? I mean, I wouldn't write this code, right? Let's go back and look at what the analysis function returns. Oh, okay, so it returns that we're depending on array. We told Cogent that, instruction 5, which is array, is a dependency, and that's how it made it into the use memo deps array. But array doesn't need to be a dependency. As Satya just explained, developers writing React code promise to write pure idempotent components, which means that any global values a component uses has to be a constant. So according to the rules of React, array doesn't need to be a dependency. Okay, so maybe we should add something as a dependency only if it might change across renders. So if we had this set of things that might change, we can use it like so. And now let's write a helper function to compute what might change is. Get values that may change, passing it function, and returning may change. And now we actually need to write this. So it's a function called get values that might change that consumes instructions and returns a set of instructions that may change. So how do we know whether an instruction might change across renders? What should go here? Starting to get a bit of deja vu. Maybe this is similar to how we calculated should memo. Maybe the instruction kind should tell us. So Satya just explained that the only thing that can change across renders are really parameters and what's returned by hooks. We're not going to talk about hooks here because that's a bit more complex, but let's handle the the parameters. So if the instruction kind is a parameter, it might change. And now we see our output looks pretty good. Array is finally missing from this deps list. But now we're missing a couple, right? We have this thing called make songs. And make songs is used in this unshift call. That doesn't make it into the dependency array. What's the issue with that? Well, if we look closer, make song reads from user, which is a parameter. It might change. So as a result, make song might also change across vendors. So not only do we have to look at the instruction type, we also have to look at the values that this instruction uses. And if a value that this instruction uses might change, this instruction itself might change. So ID is this instruction that we're currently processing, and used is a value that it uses. And finally, our dependencies array look a little bit more sane, right? But there might be something else in the output that looks a little bit off. Any guesses? So we're done with building dependency arrays. It's not there. Unshift. Huh. What's wrong with that? Well, according to the rules of React, if you call useMemo, or if you memoize a value, you shouldn't change it after the useMemo call. So here we're calling array.from to create a new list of songs. And after the useMemo returns, we're kind of writing to it in another useMemo. So if you're all doing code review, you've all failed, except for that guy. This would break prod. You might get some really nasty tearing errors. So the issue is that these two useMemo blocks should actually be merged. Really, these three should be merged into a single one, so that we're kind of creating array.from songs and changing it within the same memo block. So this isn't possible in some languages that you see, like Haskell, where if you're working with record types or primitives, but because this is JavaScript and just plain arrays, this can happen, and we need to take care of that. So the solution is pretty similar to how we figured out how to avoid adding global constants into dependency arrays. So we're going to fix this here. Fix writing to existing objects. So to fix this, I need to first understand which instructions produce values that are writable. So we're going to declare another function, another helper function called getWritable values. And this should return a set of values that might be, writable, like objects, arrays, really any non-primitive, non-frozen types. And what to put here? Starting to get a bit of deja vu again. Maybe we can handle this the same way that we calculated may change. If we look at these set of instructions, really every time I call a function, I have a call instruction or an object instruction. That might give me back a new object, which is writable. I can't write to things like props or what hook calls return. So I'm going to check the instruction kind, and if the instruction kind is a call or an object, that is a writable value. Nothing's changed because we're not writing this. Okay. Also, just like how we calculated may change, anything that you read off of a writable value, like if you're doing array access off of an existing array, that might be writable as well. So we're going to look at the instructions that this one uses, and if it is writable, if it uses a writable value, the result might also be writable. And this is really an over-approximation here. We're really calculating the set of maybe writable values, and this is maybe different from type systems like TypeScript or Flow that calculates precise values. Since React compiler produces memo blocks, it's better to be overly conservative and assume that values are writable, then assume that they're not. So this is really an over-approximation of all the values that are writable. So this part is done. Now let's figure out the second part. Now that we've figured out that array.from might produce a writable value, we need to figure out that unshift might be writing to that. How do we do this? So get writable values. And similar to our previous analysis for dependency arrays, we're going to get the writable values first and then use them. So the only instruction that might modify or write to an existing object in our little instruction set is calling out to an extra function. We don't have things like reassignment or assigning. We just have like 5 instructions. So this is pretty simple. If the instruction kind is a call instruction, that call instruction might be writing to things that it consumes. So we're going to look at what values that call instruction uses. And if that thing is writable, we're going to assume that maybe this is a write. So we're going to tell CodeGen this by writing into this results list. This is some cruft for creating a new one if we don't have one yet. And we're going to just add the current instruction. So if I am a call instruction and I'm maybe reading this or arguments that are writable, I might be writing to them. And now our output actually looks good, hopefully. Any code reviewers in the audience with a discerning eye? Okay, everyone's too afraid to say anything after that last mistake. Okay, we're done writing code. This is good. So I know I just said that we're done writing code, but like I'm really happy with this compiler we just built, and I just want to try changing my test case. Just want to add like one more thing. If I wanted to push my favorite song to the end of all of my music players, that should be fine, right? Oh no, what's the issue there? It's the exact same issue as before, except there's one little difference. Unshift thinks it's reading from array.from. It thinks it's changing array.from, and push thinks it's changing this whole other value called items. And we currently don't know that array.from and items might be the same thing. So if we step through, if we print out the set of writes and step them through, we see that on instruction 10, which is declaring items, we think that the only write to items is instruction 12. But that's not the case, right? Like items might actually be the same as array.from. That's a bummer. I think we should give up on this thing. No React compiler. It's too hard. Well, fortunately, I know a one-liner that can fix this. It's really quite simple, much easier than everything else we've done. If we can just understand this thing called aliasing, life would be good, right? So now this is the end of the demo, but I want to talk about one more thing. So this use memo is not actually what React compiler produces. So the compiler will generate a different type of output with if branches that's a little bit more performant than use memos. And it also gives you some kind of more opportunities to do branches or conditional memoization. So I'm going to give you a peek of what that looks like by passing in this optional third parameter. It's just full of these called enable real output. So this is what the real output would look like. Cool. Let's see. Okay, I'm glad it worked. I had no other backup slides prepared. My teammates all asked me, what are your backup slides? And I told them we're doing this one. So yeah, we wrote React compiler. That's pretty cool. But you're telling me that it only takes like 20 minutes to write? Well, we wrote kind of two parts of React compiler. The part where we understand memoization, like the dependencies, as well as understanding mutability instructions that might modify other instructions. There's kind of a lot of other very fundamental parts of the compiler that we haven't touched on. And just to give you an idea, the bolded parts are kind of passes that we've walked through, and the rest is you can find on the playground if you're curious. But I mean, we should still be really proud of ourselves. Analysis that looks pretty much exactly the same as the code that we write powers the React compiler, as well as ESLint rules and a lot of other JavaScript transforms. I mean, in the end, it's all just sets and maps that store information about some representation of your JavaScript. So, thank you.
Let's go one more time for Satya and Mofair. That was just, live coding is one thing, building a compiler real time is, or a portion of it is fine. But yeah. Yeah, I love Lauren's trick for that, for attention grabbing. So if you see another speaker continuing to drink on stage, please, let's keep it going. All right, so our next speaker has been very visible throughout the React community. So I'm probably not going to dive in too much into an intro in terms of their background. But Ken, the first time I met Ken was actually React Conf 2019. And the way that it happened, I think it was during karaoke. And I think there was a lot of your typical karaoke classics, Sweet Home Alabama, Sweet Caroline, and whatnot. So I was like, you know what? We're flipping this. So I played a Caribbean classic by a band called Casa, which is composed of a lot of Caribbean artists from across different Caribbean countries. And I don't know, I was vibing. People seemed to be enjoying it. And then I just grabbed Ken, and we were just dancing on stage and vibing. So that was really like a first interaction with Ken, and told me how warm of a and welcoming of a person that he is. So let's give a huge and warm welcome to Ken Dodds. Thank you.
You rock, dude. All right, hello everybody. This is Cody the Koala. He's going to join us. I am so excited to talk with you all about React Server Components. My talk is titled, "And Now You Understand React Server Components." And it's my hope is that I can say that at the end of this talk. We'll see. Wish me luck. Okay, before we get started, anybody who's been to one of my talks before knows what's about to happen. I'd like everybody to, if you're physically able, join us, stand up. This is moving your body to get blood flowing because your brain needs blood. So stretch out your arms in front of you, squat down like this, and come back up. This is an air squat. Do I need to come over here and demonstrate that? No, just, we're going to do 12 of these together. Count with me. Ready? 1, 2, you got to count. 2, 3, there we go. 4, 5, you're already feeling it. 6, the blood is going through your veins. 7, 8, 9, I'm seeing some smiles. You want to start over. 1, no, 2, 9, 11, 12. Okay, stretch over your head as high as you possibly can, and even higher than that. And then over to one side, and over to the other. Okay, now you can sit down. That feels great, yeah, right? So I understand that when you clap, I drink. Is that how this goes? Okay, sounds like a messed up drinking game. So this slide showed up earlier. My face showed on it too many times, and now it's been corrected. So here are the people that were supposed to be shown earlier. Love these people. They're awesome. So thank you all for being a great community. So let's get into it. Back in 2020, when the React Server Components was announced, I remember some cognitive dissonance. I was like, why am I not super stoked about this? I'm normally so stoked about what's going on in React. And I thought, oh, well, Remix solves all the problems that they described when they announced React Server Components. So I guess I'm not excited because Remix already solves all those things. Well, it turns out I was wrong. I was missing something. And if you had a similar feeling, you're also wrong. You were missing something. And eventually I came around. And there are a couple things, really important things, that React Server Components can do that Remix cannot do it by itself. Next can't do it by itself. None of these frameworks can do by themselves. React Server Components is an enormous innovation. And my hope is that I can bring you on in my journey of discovery for for React Server Components and how they really work. So I built a framework on top of React Server Components. Mine's like pretty simple. It's for educational purposes only, but it changes you. You know at the end of Lord of the Rings, where Frodo and his friends make it back to the Shire, and they're like having a party, and all the people around them are like the same, and they're having a good time, but Frodo and his friends were totally changed. Like, I've seen a new experience. I've had a totally different experience from all these people, and so now I'm Mary over here, feeling totally changed, and here we've got some other Redwood and Waku and Remix. Oh, sorry, not Remix, goodness. React Router v7. And we made it to Mount Doom, and we threw the ring into the fire. Huh. That's interesting. So maybe you're feeling like, I don't understand React Server Components, and at this point, I'm afraid to ask. How many people are feeling that way? Really? You're all like, it's no shame at all if you're worried about, maybe you're too afraid to raise your hand. I guess I should have thought about that. My goal is to explain it in such a way that it's simple enough for anybody to understand. So hopefully I managed that in this talk. And the way that I'm going to do that is we're going to build a framework with React Server Components together. And I found that this is an extremely efficient way, or maybe not the most, sometimes it takes a lot of work, to be clear, but it's a really great way to really understand a technology. It's just build it yourself. It doesn't have to be perfect, but just getting the mental model right. I learned this from my friend Merritt Christensen, who I think is in here. I was learning JavaScript, and he said, hey, if you build _JS, you'll really learn JavaScript. I never did it, but I've carried the advice with me forever, and it's really been helpful. So just like a speed run, if we're playing Legend of Zelda, they always have these rules of their speed runs. And so we've got a couple rules ourselves. We're not going to be using a bundler, no TypeScript, no JSX transform. We're just importing create element as H for hyperscript from React. No optimizations, no dependencies, with the exception of official React, React error boundary, and Hano.js. And the reason that I'm doing this is because I don't want you to be distracted by all of the many other tools that we use day to day as you're trying to figure out what are the pieces that make up React Server Components. Is that a Webpack thing, or is that like a React thing? So we're going to go no dependencies. What we're building is an API to fetch and render server components, a bundler to bundle and render client components, which is not actually a bundler. It's a node loader, which is a runtime module transformer, and a router, a client-side router, so that we can update our server components. A couple of things I'm going to take for granted also. You're already really optimistic about RSCs. I'm not here to convince you that RSCs are the bomb. I'm just here to help you understand them. If you want to be convinced that RSCs are amazing, then watch Evan's talk yesterday. It was phenomenal. Yes. Yeah, clap for Evan. That was so good. And yeah, it was so good. And then I also assume that you know the basics of RSCs. If you don't, then go watch Lydia's talk yesterday, also a very good talk. And actually a lot, I feel like React Conf is React Server Components Conf, and plus React Native also. You're not, or you are smart enough to not do this in production because, again, we have no dependencies, no optimizations. What we're doing is not good. We're learning, though. And you're also willing to dive in for details later. So if you, actually, how many of you have gone through Epic React? A couple of you, wow, awesome, thank you. So Epic React v2 is what I'm working on right now, and what we're going to be going through is a part of Epic React v2. We're going to kind of get a preview of the workshop that I have for building React Server Component Framework. So if you want to dive into the details, you can go to that repo right now and go through the whole workshop on your own. Here's the app that we're building. It's a list detail view. We've got the ship ID and the search params and the URL. Pretty basic standard single-page app. So not even static site generated or anything like that. Just very simple. Keep it simple. No client router either. So every click is going to be a full-page refresh, everything. The project also trying to keep that simple. It's a database, public directory for static assets, server, and our UI. OK, so now I'm coming to the computer, because we're going to explore things a bit. So this is our app.js at the start. We're fetching some data, and we're passing that to the use hook, which rocks, by the way. And we're rendering that with that data with our app. So pretty simple, straightforward stuff there. And then our server is just serving some static assets. We've got our API endpoint that is sending all of the data that our UI needs. And then we have our, this is just a SPA, right? So any other request sends the index.html. Man, that's a throwback. Let's move over to RSCs. What does it take to move over to RSCs? How is RSCs different from what we've been doing for a really long time? So with the current app, we're going to request data, and then we're combining it with React components, these templates, and poof, we put them together, and now we got React elements magically, and then we send that off to React DOM to turn it into DOM nodes. Right? So the poof part that creates the React elements, we're just moving that over to the server. So actually, not a lot changes when you move architecturally when you're switching to RSCs. It's just taking that computation of creating React elements, moving it over to the server. The tricky bit is, how do you get those React elements to the client? And so that's what we're going to be doing here. So here's our API. It's just returning some data. This is what we're going for, the RSC payload. You've seen it a couple times today. I'm not going to dive too deep, and yesterday. I'm not going to dive too deep into the actual format. Some of you are thinking, why couldn't it have just been HTML? Isn't that the format of the web? Like, why couldn't this have just generated HTML? We already do that with server rendering, but there's a really good reason, and we'll talk about that here in a second. So we need to create this format, and the way that we're going to do that is in our server, we bring in, I just realized, that's kind of small, isn't it? I did look at this earlier. Oh, I can't bump it up either, sorry. Dang, I looked at it earlier. OK, so the way that we do this is with render to pipeable stream, but it's coming from this package called React Server DOM ESM. That is actually not published. This is inside the React repo, and it's not published for a good reason, because it's missing a lot of optimizations. Don't do this in production. So, but render to pipeable stream knows how to take React elements and convert it into that format. And so here in our API endpoint, instead of data, we're getting props. And then we pass those props to our app component, which we're now importing on the server side as opposed to the client. And we pass that into render to pipeable stream. It turns those elements into that RSC format and sends that off to the client. And then here in our UI side of things and the front end side of things, we have rendered a React Server DOM ESM client. That gives us a create from fetch. And that's going to convert it from that RSC payload back into React elements. And as a result, we can just return those React elements. So there's nothing special at that point. You just like convert it back into React elements, and now React just, oh, here's some React elements. I know what to do with that, and now React DOM creates DOM nodes. Magic. It's pretty cool. And I want to call out one thing specifically is, like, I'm using a server here, but you don't have to use a server with RSCs. I think the React team is trying to like make sure this can be a bundler process, but we're doing a server. We're replacing our API endpoints with RSC endpoints. OK, sweet. Now we have RSCs. That's it. So the idea is you have your app, you turn it into React elements, right? You create element. And then you pass that into rendered pipeable stream. That turns it into our special format, the RSC payload. We pass that into create from fetch. That turns it back into React elements. And then we pass it to root.render, your React DOM. And that turns it into the div. And I don't know, but I imagine what Evan was doing was really similar, just on the native side. Like this probably would be the only difference right there. So this unlocks a lot of things. So now we can have async components. Lydia already showed you this, so I'm not going to go into that. It also is streaming and being able to set suspense boundaries and stuff. Out of order streaming, super cool stuff. Lydia showed you that too, so I'm not going to go into that. Server context, I'm pretty sure you can figure that out, so we're not going into that. The thing that, up to this point, everything that we have done, we've accomplished, we could have done like 15 years ago with PHP, right? And this is why everybody's like, RSCs, they're just PHP. Like, but this is where we go off in a different direction, and we are able to do something that I've never seen before. And that is the ability to compose the UI stuff with our server stuff. And this is just so sick. But there's there's something that is important or kind of tricky about use client, which I think is why it's been hard for people to understand RSCs. So here's the use case that we're going to support. This is a little editable text thing that I've got here. So it renders a button. When you focus on it, you hit enter, and it changes to an input. Then you can make a change. You hit enter, and submits. Shout out to Ryan Florence. I stole his code from Trellix. So this is a UI thing that's happening on the client. This requires some state. I need to know, am I in edit mode, and all of that. And that's what makes this a little bit tricky for RSCs. But let's look at the implementation. Here's our ship details. And inside of ship details, this is a server component. You can see it's async, and we're loading our ship and all of that. Right here, we're rendering the editable text component. And if we dive into the implementation of the editable text component, then we'll see a couple of things that make this tricky for RSCs. And that is mostly these use state hooks, but also the action here and the on-click. So these things can't be serialized. A thing that I've heard a lot of people say about RSCs is it's just serialized JSX. You take JSX and you stringify it, basically. And I like that idea because you cannot serialize something that's in memory. Like, of course, we could somehow figure out how to persist it, but what happens when the user makes a change on the client and now they need updated server components? Like, where does that state go? Like, how do we reconcile that difference? We can't serialize this state. And so it has to live in kind of a different environment when we're generating our server components. And so what we do is we add this use client directive to the top, which Dan taught us yesterday is a door into the client world. I actually really like that metaphor. So if you missed his talk, go watch that. It was awesome. And this enables our render to pipeable stream to generate this in the output. So it's just a reference to the client component. So rather than being the actual output from the client component, we're not going to call anything in that client module. Instead, we're just going to have references to all the exports from that client module and a mechanism for loading those modules. So here we have, this is the path to that module, and here's the namespace, or the export that we're going to be getting off of that. And then throughout the rest of the payload, we're going to be referencing this particular component so that create from fetch can dereference those and get the actual component and render when it's time to render. So how do we do this? It's a two-step process. The first step is we need to take the client module and turn it into something else, because we can't run those functions, we can't create that state, anything. We are going to turn that module into a bunch of references to the exports. To do this, we're going to use a node loader. The implementation details are different for every, this is why we've got Webpack integrations and stuff like that. But for our simple scenario, we're going to import the server register RSC loader file when we start up our server. That's going to register the RSC loader. So if you're familiar with node loaders, this is like familiar to you. If you're not, it's not a big deal. Just think about a node loader as like, here's the module that's importing things. Here's the module that's being imported. As it's importing, it's coming back, and we've got this little thing in the middle that takes that string and converts it to something else before it gets to the importing module. And so this is what that loader looks like. Thank you, Sebastian, for writing most of it. But I added a console log right here so we can actually see what does the module look like when it's been transformed. So let's take a look at that. This is our source. It goes through our node loader, and before it shows up at whoever's importing the module, they're going to get this. And what this is, again, another implementation detail of this particular package, but the idea is we're taking all of the exports of the module and creating these client references, because this is a client module. We'll pass in this function that if somebody happens to call it, they're not supposed to, and it should never happen, but if they do, then we're going to give them a nice error. But then we also provide the location of the module, and then the export that we're representing. And with that information, we need to actually take this file and convert it to something else. We basically need to chop all this extra stuff off because we don't want to send that to the client. That would be silly to send the full file path. And so that's what the next step is to get it into this format, which will happen in our server. We just create a module-based path, and we pass that to rendered pipeable stream. Again, implementation detail. And then render pipeable stream will relativize all of those paths. And then on the UI, we tell create from fetch how to resolve those references to the URLs that they need to access all of our modules. Okay? And so now, with that, we can use client components throughout our application. Composing things, server goes into client, and then we pass some more server stuff, and it's magical, the things that we can do. Again, watch Evan's talk. So cool. But the UI needs to be updated. As the user is changing and navigating around and stuff, right now, they click on a link and a full page refresh, and it technically works, but it is technically awful, so we are not going to do that. We're going to build a router. And the guts of our router, we've got a couple utilities in this UI router right here. We've got our context, so this is only loaded on the client, and a couple other utilities. And then in our UI index right here, we've changed a couple of things. This was a pretty simple file before. Now we've refactored a couple of things. But the most important thing for you to understand is that we're still creating our initial content promise and everything, but we need to be able to change the location. So we're no longer just using the initial location as the user's navigating. We need to be able to change that. So we're going to stick that in state. We also need to be able to change the content because the user navigating, they're getting new React server component payloads. So we're going to store the promise in our state. And then we still are doing use, content promise, like all of that is the same as before. It's just now this is in state. It's something that can be changed over time. And that changes inside of our navigate function. We'll get the next location. We'll set that we'll update the location to where we're going. We'll fetch new content. We'll call create from fetch to convert it back into React elements, and then we'll update the content promise inside of a transition, so all the suspense boundaries work and all of that stuff. And what I find really interesting about this is if you were to do the same thing without RSCs and just like, I need to go fetch new data and render my React elements and stuff, this is exactly what it would look like. Except it would be less awesome. So I like RSCs because it allows me to do all the cool things Evan showed. So it's pretty much like, go get me the new data, update the history, all of that. And then we have client-side navigations, and our users are much happier. They'll interact with their app more. So there are more problems we got to deal with now. So there's pending UI if it's slow. That's something that we can totally deal with, but we don't have time to get through that. Also, you have to worry about history, so you got pop state and all of that stuff, and making sure you're going to grab the content when you go back and all of that. But then the browser actually caches stuff for you when you navigate forward and back. So you actually, because you're in charge, you have to do that yourself. That's a pain. And so this is why you hear the React team saying, hey, I think you should use a framework, because a framework is going to do all of this stuff for you. Oh my gosh. I messed up my slides again. Oh, yeah, React Router v7. It's the same picture. So use a framework, and then you don't have these problems. But build a framework, and you understand what the framework is doing. You get that? That is a really powerful concept. All right, so let's talk about actions. Oh, just kidding. I am over by 26 seconds. Maybe we'll do this next time. So if you really want to dive deep into all of that stuff, then the entire thing is on the Epic Web GitHub org. You can go through it all. It's intended to be self-paced. I'm giving this stuff away. I am in the process of recording the videos, and you can go buy those and go with me, travel through the journey with me. But I think that it's really valuable to have this education for everybody. So go through the workshop and dive deeper on these concepts. I think it's really valuable. And of course, give me stars, because that's how I eat, I think. And now you understand React Server Components, I hope. You all are fantastic. Thank you so much.
That was awesome. Oh, I'm so sorry. Oh my God. That was great. Excellent. As on brand, Kent always delivers a fun and engaging experience. So I have the privilege of sharing with y'all a little story. Not really a story, but as I was speaking with a few of the speakers to prepare, understand their background, one thing I realized is that the most common thing that we have is food. Obviously, I called out pastries, but I love food. I'm currently going through a kind of like a soup discovery. I'm drinking a lot of soups. I love soups. And I've been exploring soups from different cultures. And my favorite soup, obviously, and is probably like can never be matched, is a soup called jumu. It's made from this like giromont, which is like a specific type of pumpkin variant that's grown on the island of Quisqueya that was cultivated by the Taino and Arawak people. So this soup is on the UNESCO Cultural Intangible Heritage List, and it's traditionally before the start of the 19th century, it was a soup that was reserved only for slave masters. So it consists of the pumpkin, different types of grains, pasta, different portions of meats, beans, a lot of different ingredients. And it's very much a family affair. But the reason why this is so important to me is that it's like probably the most Haitian dish that you can have. It symbolizes our resilience and our dignity and our freedom for us. Why is that? It's just the food. Well, when Haitians declared their independence and became the first nation to do so, Black nation and African nation to do so, the first act of defiance and of freedom was to make this dish that was forever restricted to them. So it says, you know what? Now that we're done with you, I'm about to have my piece. So on every year, which our independence is on January 1st, which is just saying between us, like we don't necessarily celebrate New Year's Eve. We celebrate the 1st because it's our Independence Day. We do so by having jumu. So every family makes this giant pot of jumu, and that's all we eat for basically a week and a half, because there's a surplus to it. And we share and change that. So in English, I think we call it like freedom soup, but that is a little bit of me sharing a little bit of Haitian history and Haitian culture on Haitian Heritage Month as well. So for our next speaker, had a chance to talk a little bit about food, but also about his travels, which is why this is like a perfect little tangent to go to, is Lee. Let's give him a huge welcome, and he's gonna blow us away with some interesting topics. So thank you. Just let me share that. There we go. Yeah.
The AI songs are so good. How's everyone? We doing great out here? I'm gonna keep the tradition going with the water claps. I love it, so let's start. We gotta stay hydrated here, Gotta love that. How many musicians do we have? People who dabble with guitar or piano? Okay, quite a few. There's always that fun overlap of tech people and musicians, which I really like. I dabble myself. That was a lot of the inspiration for my talk title, and there'll be some themes to music throughout the talk as well too. So for the next 20 minutes, I really want to talk about how React's latest features work across the client and the server. And it's not about just the client or just the server, but really the combination of the two and how this architecture fits together. You can't have the rhythm without the blues, the drum without the bass, and I'll make a couple more music references. But hi, I'm Lee, or Lee Rob online. I love teaching developers how to build for the web with React. And I just like building great developer products. A bit more about myself. This is me and my wife, Allie. We have 2 cats, Fiona and Lucy, and I work at Vercel on Next.js. Wait, where did that come from? Who's that guy? That's me and Ryan yesterday repping the remix gear, but yeah, I work at Vercel on Next.js, which is what I'm going to talk a little bit about today as well too. Now, I live in Iowa, which is not Idaho with the potatoes, and it's also not Ohio with Ricky as well. It's right there in the middle of the United States. If you've heard of Field of Dreams, it's that. We have the cornfields, and that's an AI-generated image, but it does actually exist. In reality, there's just like data centers everywhere in Iowa, so that kind of makes sense as well, too. I'm really fortunate and thankful to be on this stage. I've looked up to so many of the past speakers here, many of you all for over a decade, and really just honored to be here. I want to pick on 2 past speakers in particular that I'm fortunate to get to work with. Who's that Pokemon? Does anyone recognize this guy? I don't know who he is without the mustache, but Guillermo here. Another one, I don't know, with this iconic pose. Who is this man? Damo, some of the past React Conf speakers. So yeah, very excited to be here. In my talk, I'm going to be building this chat widget, this intercom-like example that talks to an AI model and helps you answer your questions. Kind of simple example, but we're going to make our way through just a basic React app all the way to using some of the latest features. And React's about helping you build great user interfaces, and that means the client and the server. Some of those things happen on my device, in the browser. Some of those things happen on a different computer. I loved Dan's talk the other day. And those 2 different computers, those 2 different programs really have to work together. Sometimes that's running on a data center in Iowa somewhere, and sometimes that's happening ahead of time, or it's happening at runtime. And we're gonna get into some of those nuances as well today. So first, let's go back 10 years to the beginnings of React, and we're going to start with the introduction to our song here. I want to start by just recapping some of the React design principles there's quite a few, but these are some of the ones that I really liked. So with incremental adoption, you should just be able to start using React and not have to really rewrite your whole application. I really liked Ryan's talk the other day as well, too. Composability, like if I have a bunch of different React engineers working across many different teams, I should be able to build a component and drop it in and not have it affect the rest of my application. Components written by different people should work together well, and that's really what React does well with composability. And the final one that's probably one of my favorite ones is trying to find the common abstraction. React has done a really good job about having this kind of minimal surface area and allowing things to be developed and built in user land and user code, and then eventually finding these common abstractions that really raise the ceiling of the type of user experiences that you can build. So definitely want to touch back on some of these design principles as we move through. So let's take a look at the code. We'll switch back and forth here. See if this works. There we go. OK, so on my left, I have a server template. I have HTML, just some basic HTML. And on the right, I have my browser. And I have this chat widget going here. So I can say, hi. And this is going to talk to my model. I'm a helpful assistant here to make your life easier. And you'll notice that on the left in the HTML, I've got the messages that I'm returning back, the text area, the button. But then I need to make this interactive. I want to chat with this widget. So I have a script tag. And this is just going to use some vanilla JavaScript here. Not jQuery, although we could do jQuery. We're just going to do some vanilla JavaScript. So I have some events. I have some event listeners for clicks and key presses. And then I have a function that goes over the network. It talks to my AI model, returns the results back, and adds it to that list of messages. So pretty straightforward. You can continue building apps like this today if you want. There's nothing wrong with this. This is still a great way of doing it. But 10 years ago, a lot of folks thought, I kind of want to make this a little bit more declarative. I would love to encapsulate some of this in these reusable components and make it easy to drop them in my application without affecting any other logic anywhere else. So you might wonder what this looks like as a React component. So your HTML might look a little bit differently. You might have this root element that you're putting the React component into, and then you kind of compile this into still a script tag that's running in the browser. So let me go over to here. We'll go to the React version. It's going to work the same way. Functionally, it's the same thing. But we're able to express this in this encapsulated component called a chat widget. We have some state. We have some effects here for focusing on the input or being able to submit the form when I press the enter key. And then we still have that function that allows us to send a message, go over the network, and talk to our model. But there's one big difference here, which is that the HTML is in the JavaScript, right? We have our JSX here, and we're able to put all this together, both the logic that determines what UI we show as well as the UI itself. Now, 10 years ago, this was class components. I think we also still remember those. But I kept it with hooks just to make it a little bit easier to write. But this is really how we got started building React applications. And it's still a great way of taking advantage of the client today. So I wanted to show that first. But then I want to talk a little bit about how the ecosystem has evolved over time. So let's move a little bit forward past the start and kind of into the chorus of our song here. What's happened since then? What's it been like for the last 10 years of React? Well, we've had quite a bit of exploration. I mentioned that React has this minimal API surface area, and it's allowed the community to take that and create and extend and build all these amazing primitives and libraries and frameworks on top of these really amazing core primitives. And I really like this visualization of how things have evolved over time, especially because, as we'll talk about today, we don't know what's going to happen next. We want to see what everyone builds with all of these powerful new tools. So I want to talk about a couple main categories of exploration in the ecosystem. And let's start with routing. So going back 10 years ago, React Router was introduced or talked at React Conf here. And it was really one of the first solutions that gave this declarative way of defining the routes in your components. And there's been a ton of exploration in routing since. And still, this is a really powerful pattern to build off of. The second one, a big kind of category of community exploration, is data fetching. So in 2016, Next.js came out with this server-rendered React framework that took the React component model and it extended it to be able to have this function called getInitialProps that allowed you to do data fetching. And not only could those data fetching functions be placed in your components, they could also be prefetched ahead of time to try to give you the best benefits of a server-rendered React application, but that snappy SPA-like feel when you move between pages that we all love from React as well, too. And then on the right, other frameworks like Remix have came and evolved and added some additional things to this as well, too, like streaming with defer and actions to simplify forms. So we've seen just a ton of exploration in this space as well, too. And the last category I'll talk about is just broadly like caching and invalidation. There's been a number of libraries here, React Query or Tanstack Query, SWR, Apollo, like lots of libraries that have made it easy to co-locate your data fetching with your component. You want to put that logic next to the UI that it creates. And I think Tanstack Query has done a good job of defining your cache keys easier, doing patterns like infinite scroll or pagination or retrying fetches. Like, there's a lot that goes into this, and I think I'm really proud of a lot of the libraries in the community that have pushed this forward. So let's push a little bit forward towards the outro of this song. We've heard a lot about React 19 and a lot of this new functionality across the client and the server. If we take those original React design principles and we apply them to today, what would that look like? What would that chatbot look like? Well, let's go back to the code. And OK, so I also have a Next.js application running that I'm going to pull up. And what I've done is I've taken that client-side React component that I was building from before, and I've dropped it into a server framework. And we're going to start just only talking about client features, but then we'll make our way to some of these newer React 19 features that we've talked about. So let's start with this first page. Now, what you're going to notice is it's pretty much the same as before, but I've made kind of two big changes. One, I moved from a controlled component to an uncontrolled form here. So I'm just reading the value in. I'm updating the state with the messages that I have, and then I have this client action. I have this asynchronous transition. I'm still going over the network. I'm making a fetch out to my AI model. I'm getting the result back, and I'm updating the state. This allows me to do that work in the background, and then when it's done, I can update my UI without having to block any of that UI. So let's check and make sure this works. What is React? Hey, there we go. It still works. Awesome. OK, so we can still talk to our AI model. That's great. We've made some progress here. But it'd be great if I could disable the button while that state is pending so that I don't spam that button and click it multiple times. Well, luckily, I have this transition, and it has this pending flag that I can use. So I can just go down to here, and I can throw on disabled and say, if it's pending, then we can just disable that. So that's great. But still, this is a little verbose. I had to manually define my transition. And the the form didn't reset. I want to clear out that input after I submit that. So how can we make this a little bit better? Well, let's go to another version of this. And let's talk through a couple small changes I've made. So we'll start on line 27 here with this form. I'm now using this action. And what you'll notice, I've taken that client action, I've moved it up into use action state. And it allowed me to simplify a couple things. One, I don't have to define that transition manually anymore. It's doing that for me. And it's automatically going to reset the form for me as well, too. So that's pretty nice. I get access to the form data. Again, still going over the network, get the result back, and then I update React state. Now, you can store state and use action state, and right now I'm not using that. Maybe we can make that a little bit better in the future as well, too. I have the state, the action, and again, I can still use the pending flag from this transition to disable that button. So let's see if this works. What is JavaScript? This is just forcing you to clap for my demos. It's great. No, just kidding. So this is a little bit better. We've reduced some of that boilerplate code, but I feel like there's a way that we can streamline this even more. So let's do another version of this. Let's simplify this a little bit more. OK. Now in this version, let's focus in specifically inside of the action. So we still get the form data message, but you'll notice now we're not going over the network anymore to a fetch to some separate API somewhere else that's talking to that large language model. Instead, we're just calling a function. And we're calling this function that's a server action. And this send chat function is being imported up here at the top. And it's telling my bundler, hey, we're going to make a portal into the server world. We're going to be able to call this function and go from client to server. So let's take a little detour into this function. At the top, we have that directive for our bundler, use server. And then we have this function, send chat, that's doing the heavy lifting of talking to our large language model. This is using Llama 3, the 8 billion parameter model. Thank you, Meta, for Llama 3. It's great. Yes. And we get the result back, and then we return it back. So I didn't have to manually create an API endpoint anywhere. I didn't have to have a separate service. I could just build this kind of full stack app with the single unified React programming model. So that's really handy. Let's make sure this still works. Yeah, yes, it still works. OK, now I want to mention something, though, while we're here, which is I didn't have to manually write the API endpoint, but does it still exist? And the answer is yes, it does still exist, and I can demonstrate that really well. I'm just going to copy this curl, and we're going to open up the terminal here. We'll make a new tab, make this a little bit bigger. So if I post back to this route, and I include this header for an ID for the action, what you're going to see is that I can still call this directly. So it is still an API. I just don't have to kind of manually spin it up myself. The reason why I wanted to mention this is because the best practices for building APIs still apply. We still want to have a data access layer. So you still want to have your authentication, your authorization checks as part of this as well, too. It doesn't remove you from thinking about that as well, too. So just wanted to quickly mention that as well. OK, let's go back to our chat component. So we talked about this line, but there's a couple other changes here. I updated the state, that use action state, to hold the messages that I get back from my large language model. So not only do I set some initial messages or some initial state, but then in my action here, I return and kind of merge the old state with what I get back from the server. Now, you might have noticed that when you opened up this chat widget, there was some new information here. All of a sudden, my chat widget knew who I was. It said, welcome, Lee Rob. How may I help you today? So how's that possible? Where did that information come from? A server had to go fetch that information about my user and forward it to the client so that I can use it in this component. And if you look at my component here, this chat widget, it doesn't know where the user came from. It just has this prop that was passed to it from the server. And then I can use that user information to construct the message. So let's go up the tree one level here. And let's look at that server component that helped us get that information. So going back to finding that common abstraction, what would it look like in a React model to be able to fetch data? Well, I think it makes sense to just mark a function as async and just await some data. I think that sounds like a pretty helpful way of doing this. So I go talk to an API, I get some information back about my user, and then the server component can take that info, it can serialize it and pass it to my client component. So that's where this component is being used. So I think that's really powerful, and it really simplifies the pieces that I need to be able to put this together. Yet I'm still left feeling like maybe we could take this just a little bit further. Now, one of those React design principles was composability. And really everything we've talked about thus far has been able to compose together. So you might imagine a world where you could take something off the shelf, like a next generation of UI component libraries or React libraries, that make it really easy to build these type of experiences. So maybe if I just delete all this code and export default function page, and I might imagine I could just do like, I don't know, chat with user or something like that. I don't know, something like this, maybe leave-rob. Yeah, something like that might work, I guess. Let me just see if this works. What is React? Wait, that works? What if I told you that package was real? I published this package. It's a demo. Don't put this in production, please. But I published this package that actually takes everything that I just showed today, server components, client components, server actions, all that good stuff, and it all composes together in one component. And maybe I want to change this, and we're going to have a different user now. It's that easy. So you can imagine this next generation of components built this way. I get really excited about it. I think it's going to be, it's going to be great. Let me go back to my slides. Okay, to help visualize that a little bit, I built this little diagram. So I had that page, that server component. It was going to the client. It was talking to the chat component. That was creating a portal back to the server to call that server action. And it was all communicating with these third parties, a database or an AI provider in this instance. And it's all encapsulated in this chat with user component. I think that's great. So we're at the end of our song. But actually, it's kind of the extended cut 10-minute version, Taylor's version. We've got 10 more minutes, 10 more years of this to come. And I'm really excited about what comes next. To kind of make this more real, I wanted to talk about a Next.js and Vercel customer who's building something like this. This company called Chatbase. They built this MVP with all of these new React features in 2 months, and they're already at $3.5 million ARR, which is just incredible, so kudos to that team. But you can imagine this next generation of these components that are really interactive and allow you to take the best parts of both the client and the server. And like we saw yesterday with Evan's talk as well, too, like there's so much potential here. Just to kind of show the art of what is possible here, something we've been spending a lot of time thinking about is how all of the things I've just talked about so far can help us define the next generation of user interfaces when we're building with some of these powerful large language models. So you might imagine maybe I'm building a United Airlines support app, and maybe I want to do something like tell me all the flights to Rome today, and I want to have this interactive widget that I can click on and choose the flight that works best for me. Then maybe I want to have this interactive seat picker where I can choose the best seat. I can integrate with third parties like Google Pay or Stripe or your favorite payments provider and connect to those APIs, again, across the client and the server. And then I get a boarding pass back for my flight. All of this is possible. This is a real demo, by the way, gemini.vercel.ai. All of this is possible thanks to the work of the React team at Meta and all the innovations over the last 10 years that build on top of each other, all the concurrent features, streaming, server rendering. It's just really exciting to see it all come together in something like this. And I can't wait to see the next generation of components and packages built on all of this technology. So thank you very much.
That was great and amazing. All right, so after mentioning, obviously, Subjumu, I was out there kind of like starving and rumbling, which is a good sign because now is lunch break. We're going to break for a little bit, and then we should be back here at 2 p.m. PST. Bon appetit.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building. Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun. Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you You talk to the database, access the file system. And with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building. Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun. Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building. Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun. Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
All right, now that works. There you go. All right, welcome back. Those of you outside, we are about to resume, so you're welcome to rush back in for the vibes. Now, before we go in, there was a really interesting message that popped up. Programming with Michael on the live chat. There's a young 13-year-old who asked, well, he really wants to know how to get involved with the community. He started, it's been 6 months. So I want to let you know that the first step you can take is to go on meetup.com and do a search for React in your local area. And that's like a really great first step. And we, the community, will be reaching out to you for other channels and spaces where you can learn more and get involved with the community. Let's give it up for Programming with Michael for asking a great question. Oh man, I love that. Man, at 13 too, man, I wish I was a 13-year-old that was interested in this thing, man. Because I'll tell you right now, I'll be in my bag. So our next speaker coming in from Canada is a really nice and very jolly fellow. His favorite emoji is also the rock on emoji. So feel free to clap every single time he apologizes. But let's give a nice warm welcome to Ryan Albrecht.
Let's do that. Let's do that. Hello, everyone, and everyone on the live stream. So I am Ryan Albrecht, and I'm the lead front-end engineer for Session Replay at Sentry. And so because we're coming from Sentry, I want to talk about bugs and how to fix them faster with Session Replay. Bugs and debugging, always a problem. I think everyone in the room is the cause, so you all have yourself to blame. But we're going to make it a little bit easier today with Session Replay, and I'm going to show you how. There's 4 things I want to walk through today. And we don't have a lot of time, so I'm just going to get right to it. But basically, look out for privacy. We're going to talk about dev tools and how we're bringing that from the browser into Sentry so you can debug whatever's going on other people's computers. And of course, because this is React Conf, I'm going to talk about how this is React-aware and all the little tricks and things that we're trying to do to make it more of a React-aware experience. And we're also going to talk about hydration errors, my favorite bug that it seems to be impossible to solve, and how we're going to make that a little bit easier when it happens in production. So that's a big, big difference. So let's get down to it. So this is my website. It's taking over the world right now on poketalk.com or whatever. It's basically a marketplace, a storefront where you can see all the Pokemon. Yes, we've caught them all, in case you're wondering, except for Charizard. He's out of stock right now. But you can basically browse the site, see some Pokemon, add to the cart. When you're ready to make a purchase, check out. Very simple stuff, right? So earlier this morning, I was waking up and noticed I had an error on my site. So Sentry alerted me to this, and it was a network error. Not the most descriptive. It says Ajax response returned 500. So that's not good, but this is incredibly not helpful. Luckily, Sentry has collected a lot of information and is trying to make this an actionable ticket. So let's see what we have. One of the first things we have here is a stack trace. So we can see that this is coming from our API posts helper. So we've unminified the stack trace. We can see what the code was that I actually wrote. But this is still actually not super helpful. We can see the same message here, API response returned, and I know it's a 500. What I would really like to know is what was the request, actually? Like, what URL did we hit? So that's kind of missing. Yeah, if I'm going to reproduce this, I have to, like, trigger a 500. So this is actually where Session Replay comes in, because I don't actually have to trigger this. Someone already has. And with Session Replay running, we can see exactly what they did. So we keep scrolling here, and this is the Session Replay. I'm going to zoom in a little bit and give you the preview. So here's our user session. Right in the middle is when the error happened. And with Session Replay, we're going to be able to see what happened before the error, but also what happened afterwards, and be able to tell if this was a serious error or not. So let's give this a run through. So here's the user. They've clicked this button. They're clicking around. I guess they're waiting for it. And then there's the error, and there's the error message. So we'll pause it there. Not a serious error. The error message popped up. Presumably, they were able to try again. Let's dig in deeper. So by looking at the full replay here, We're going to see what happened and dive into this. So because it was a network error, and if I click this, I can go back, what I'm going to do is start with looking at the network tab. But even before that, I can see that there's 2 errors here at about the same time. So what we can see is that even though the front end, or what we can see is that the back end threw an error, and then the front end didn't handle it. So if we had 2 teams, you might be thinking one team might fix it and the other one won't. But by co-locating this information together, we know that this is actually one problem, and it's just popping up in 2 different places. So anyway, network error. Let's look at the network tab. And jump down to that timestamp. There it is, the post 500 error. It just jumps out right at you. And so now we've just learned what was it that they were trying to do, and what was the endpoint that they were trying to call. So my reproduction steps here are now possible, whereas before it was impossible. You might also notice that this replay kind of looks like the website, but it's a little bit hard to use. I'm going to zoom in again here. That's the privacy stuff working. So by default, I have no idea what's on your website. I have no idea what's on my website some of the times. And so Sentry takes the position that anything on the website might be privacy, or might be PII, and might be sensitive for us to capture. And so by default, we're scrubbing everything. And this is happening on the browser. Nothing is escaping onto our servers or out of really the user's browser. So you can see here, all the Pokemon names that they had purchased are starred out. All of the pictures, which might be user-generated or might be profile pictures or anything like that, all blocked out, and this is happening on the browser. And then, of course, you can peel it back. And so on this site, we've noticed that the menu and the logo, or the page title, those are very static, so we can see those. We've chosen to reveal those. Privacy is very important. Getting back to debugging. I'm not going to jump into the code because this is actually just an if statement that throws the 500, so it's not too exciting to look at the code right now. But if it were a more complicated problem, what we can actually do is opt in, because of privacy, to capturing request and response bodies. So as your page is making requests and responses, as if you were looking at the dev tools in the browser, we can see the data here as well. So it's blocked in the left side here, but on the right side, we can see what they were trying to purchase, and there was 4 different Pokemon, nothing too crazy. But the response is what was giving us the 500, so let's click into there. And now this is actually pretty useful. It's an inventory system error, invalid ID. So one of these Pokemon is an invalid ID, and it's even giving us file names and line numbers. So now not only do we know the URL that was hit, which we didn't before, but we know what the actual error was on the server. We've been able to connect it, and we can see what the result was in the UI. So this is just one of the ways that Session Replay makes debugging so much better. Connecting all of the data that we have and putting it under one umbrella. We talked about errors and backend errors. We also have trace data, so performance. If you're looking at a slow transaction or a slow page load, when you see the loading indicator on the left side, you can look at the tracing data and figure out what was the database call that caused it to wait. OK, so privacy. We talked about bringing in the dev tools here. Now I want to talk about the React-specific stuff. So one thing we've always had on Sentry is a notion of breadcrumbs. And it's always been leading up to the error. So with Session Replay, of course, you can see breadcrumbs before and after an error. But you can now we're introducing React-aware breadcrumbs. So I'm going to try to find one here. The checkout button. Oh, let's not click that. So the checkout button is obviously checkout button.tsx. It's a React component. And with our new Webpack build plugin, we're able to annotate all of your React components, so that way when an error happens and as we're tracking breadcrumbs, you can see exactly what components were used. So in this case, if I wanted to know which button did they click, maybe there's multiple checkout buttons on the page, I can track this CSS selector through the main tag, through the shopping cart component, through the form element, and know that it was the checkout button that had the interaction. So if there was, for example, a missing loading indicator or no response, I know that I have to go in here and edit that on-click handler. So I think that's pretty cool. This bringing React in to the debugging experience. Whereas before, you have your dev tools in development time, you can get the same kind of experience in production. Now, the last thing I want to talk about is hydration errors. And so we recently poured our old documentation site from Gatsby into Next.js for dog fooding, but also because Next.js is just so awesome. And that caused a bunch of hydration errors. And so normally, if I was making small commits, it would be easy to say, like, oh, there's a new error. Let's look at the recent commits and try to fix it. But in this case, we had a big problem because it's like thousands of lines of code, and there's tons of hydration errors all over the place. So this is a real Sentry right now. But of course, everybody's anonymous, so I can show it to you. So we caught some hydration errors. And this is what it looks like. So here on the left is, of course, our doc site. Somebody's using dark mode. And we've got here 3 hydration errors. I'm really looking forward to React 19 when this just goes down to 1. But in the past, when you're in production, the hard part of solving these things is that it just says hydration error, go see React, whatever that error code is. I think there's a couple of them. It's really kind of useless. And so now what we're doing is we're going to be able to show you a diff of exactly what changed. And so here is the page, and here is the diff of the code. And now I can tell you what happened in production and why there was a hydration error. And in this case, the style tag has now been added, and there's some HTML that probably got changed. It's actually kind of hard to look at and kind of hard to read. Maybe this docs layout thing is important. So we also have a visual diff, and that looks pretty strikingly different. So whatever is going on this page, I can tell, and I can dig in. And of course, because replay is an HTML snapshot of the page, this is not just an image. I can right-click on it and inspect the DOM on both sides. So whatever is different, you can get the textual diff of it and also the visual diff in order to debug things. I think that's pretty cool, right? I've got some other more subtle examples here. So here's another hydration error. It's the same kind of crazy text at the beginning. But this one, see if you can spot the difference. It's actually this menu bar up here. And yes, this is all HTML, so you can hover over it and see it. So something is causing this to load in afterwards. And also this sidebar thing here. So these are real production issues that we're going to go fix next week, because we just launched this new site. But now we can, because we have hydration errors with session replay. So I hope you guys can all give it a try, and thank you for listening. And I hope to see you soon on Discord and everywhere else. Bye-bye.
Great. Our next speaker is, I'll have to give her the trophy for probably like the gentlest and most sweetest person that I've met all week. Like, she really brightens my day, and she really cares, and it shows in the topic that she decides to be presenting today. I think I've kind of like tried to synthesize a lot of vibes that a lot of these speakers have from my opportunity to really get a time to sit down and vibe with them. And her vibe really makes me want to go frolic in a field of flowers. Like, it's just really uplifting. And I can really appreciate that about a particular person. So, joining us from Estonia, this person is repping the wonderful and currently resilient nation of Ukraine. When she gets on here, I want y'all to give her a huge amount of love and support. Let's give it up for Katarina Portnieva.
Hello, everybody. Let me first do a little bit of a technical check. Hey, I have quite a lot of sound in my presentation, so we need to make sure it works.
Sound check.
Yay. How's the volume?
Sound check.
Everything great? OK, cool. Now we are ready to start, and I want to talk to you about accessibility. Interestingly, today is the Global Accessibility Awareness Day. So it deserves a round of applause. So let's celebrate it together by learning more about accessibility in React. Accessibility is all about ensuring equal access for people with disabilities. And you are likely familiar with accessibility features in the public space, such as curb cuts, ramps, elevators, and sliding doors. They all help to remove barriers for people with disabilities. But similarly to how curbs can create challenges for somebody using a wheelchair, a lot of the features of our digital products can create barriers for people using assistive technology, like a screen reader, voice control, switch device, or Braille keyboard. And in this talk, I will cover some basics of accessibility on the web, and then we'll explore several examples on how we can avoid creating accessibility bottlenecks in React applications. But we've got quite a lot to cover, so let's dive right in. And first, let's start with some foundations. When web pages get rendered, HTML is parsed by the browser and is transformed into a DOM tree, out of which browser builds visual UI that you can see and interact with. However, it doesn't end there. In parallel to this process, it also builds an accessibility tree, containing all important accessibility information about elements on the page, which then gets exposed to assistive technology like a screen reader and is used to navigate the page. But it's a lot easier to understand when looking at the example. For this HTML page, accessibility tree will look something like this. Each element within accessibility tree has its role, which describes what kind of element it is, what is its purpose, and an accessible name, which identifies it on the page. In case of this button, it is inferred from its content. Additionally, it can contain a lot of other attributes that describe it further or communicate its current state. Now, this whole tree is exposed to the assistive technology by the browser via Spatial API and will be used to navigate the page. Let's see what that might look like.
Page. Web content. Heading level 1. Hello. Waving hand. Image. Main. Let's learn about accessibility. Start. Button.
As you can hear, Screen Reader announces information straight from the accessibility tree. It uses accessible role and accessible name to describe elements on the page. And while in this example we navigated the page sequentially, Screen Reader users have a lot of shortcuts to navigate page by headings, links, interactive elements, and so on. And this is exactly why using semantic HTML is so important. Semantics convey meaning. While we could have created same-looking page just by using some divs in our markup, it would have made it impossible to navigate and interact with. And there are over 100 different HTML elements that we can use that all come in with built-in semantic roles, states, and other attributes. And by using them, we can get a lot of built-in behaviors for free, but also made our code more meaningful and accessible. However, sometimes for modern UIs, native HTML might not be enough. So in those cases, we can use ARIA. ARIA stands for Accessible Rich Internet Applications. And it is a spec that defines a set of HTML attributes that we can use that give us granular control over accessibility tree. For example, we can override accessible role of the element using role attribute. However, it's important to note that all of the ARIA attributes only provide semantics. They don't modify behavior or appearance in any way. So if we were, let's say, set of role of a button to the div, yes, it will get updated in the accessibility tree and will be communicated to the user as a button, but it won't make an actual focusable, pressable button out of this div. So we would need to implement it ourselves by adding some functionality in CSS and JavaScript. And we can generally treat ARIA as a promise. We are promising to the user that this div is supposed to be a button, and it's important to deliver on this promise. So in most cases, it's easier and more accessible to just use native HTML. It is even noted inside the ARIA spec. Essentially, the spec says, don't use ARIA unless you absolutely have to. However, where ARIA shines is implementing patterns that aren't supported in HTML yet, like tooltips, tabs, combo boxes, and so on. Additionally to roles, what we just discussed, there are also a bunch of other ARIA attributes, all prefixed with ARIA-something, that you can use to set state and other properties for elements in the accessibility tree. In a way, using ARIA is like performing precision surgery on top of the accessibility tree. It gives us as developers a lot of power, but, well, with great power often comes great responsibility, And research shows that pages that use ARIA have more accessibility errors than pages without, which just shows that this amount of control, it's easy to mess things up. So generally, when you use ARIA, you need to be careful, use it only where necessary, and be responsible when doing so. Now, here we've talked about assistive technology, how it works on the web, accessibility tree, semantic HTML, ARIA. We are ready to dive into some examples I wanted to cover. And let's start with the first one, which is icon buttons. If we have a button with an icon usually serves purely decorative purpose. However, icon itself would be getting announced, which also is not necessary, but also can sound confusing. To prevent it, we can hide it from the accessibility tree. To do it, we can use ARIA hidden attribute. Everything inside will be excluded from the accessibility tree, therefore won't get announced to the user. But often in modern UIs, to fit more different actions on the screen, we use buttons without any text label at all, with only icon to communicate its purpose. In this case, button wouldn't have any accessible name, so screen reader wouldn't know how to announce it.
Button.
We can set this accessible name by using ARIA label attribute. And this is probably something you've seen a lot. However, it also has some limitations. For example, in most browsers, it won't get translated if translation feature is on. So I would like to show you a better way. We can add a button, a label within the button, as we usually would, and then hide it from the visual UI. This way, we also will be following that first rule of ARIA that we talked about by not using ARIA. However, our usual hiding techniques, like display none, will actually exclude elements from accessibility tree too. So we need something different. There is this visually hidden technique that we can use, which is basically the CSS snippet that shrinks the element and hides it out of the view. In this case, it will still stay within the accessibility tree and can get announced to the user.
Edit post button.
And this is a very common pattern, so I would suggest to extract it into a separate component, like visually hidden here within your design system, which makes it a lot easier to reuse, but also makes the code more readable. Now, by implementing icon buttons, we learned how to hide things. We learned how to hide decorative elements, like icons here, from the accessibility tree using ARIA hidden attributes, and we learned how to hide elements from the visual UI using visually hidden technique. Now, in our next example, let's talk about accessible text inputs. Input needs labels, because imagine filling a form like this. It seems confusing, right? Unfortunately, this is the experience for a lot of people using assistive technology today. So it's important to implement inputs accessibly. There is HTML label element that we can use, and when positioned near the input, it will already visually convey the information. But if we listen to the screen reader,
edit text, blank,
you can see that it doesn't pick it up. To understand why, let's look into the accessibility tree. We can see that this input doesn't have any accessible name, which is exactly what screen reader uses to announce elements. And this is because screen reader doesn't know that this label belongs to this input. To fix it, we need to explicitly connect label element with the input element using foreign ID attributes. Now, contents of the label will be used as an accessible name and therefore can be announced to the user.
Username, edit text.
You can also use implicit binding for the labels by wrapping label around the input. But generally, this method is less supported by different versions of the screen readers. So if you're using this, explicit binding with foreign ID attributes is still preferred. However, in modern UIs, there are still some cases where you might not want to display a label near the input and rely on additional context around the input to communicate its purpose. In those cases, I often see placeholder being used. But placeholders also have quite low support in assistive technology. So we need a better way. While we could use ARIA label here again, a better, more semantic way would be to use visually hidden label instead. We can take our component, visually hidden component from before, and make it more flexible by providing ability to set semantic HTML element that is rendered as, known as polymorphism. Now, we can render a visually hidden label with this visually hidden component, which will provide it within the accessibility tree, and therefore can announce to the user. We generally want to keep labels clear and concise, but sometimes we need to provide additional information. Like different instructions or hints like this. To implement it, we can just place the text underneath the input. But again, because it is not connected to the input, it might be overlooked by the screen readers. When we talked about accessibility tree, I mentioned that all elements within accessibility tree can have accessible role and name. What I didn't mention is that they can also have an accessible description, which would be empty by default. We can set it using ARIA. We can set an ID for a span containing the description, and then connect it to the input using ARIA described by attribute. Then, contents of the span will be used as an accessible description, which is typically announced to the users after a pause, like this.
Username, edit text. Must be between 3 and 20 characters long.
As you've noticed, we often need to use IDs to connect different elements together for accessibility. And because IDs need to be unique, it can create some challenges. So to make it easier, React has a super useful hook called useID. You can use it to generate unique IDs and then connect different elements together for accessibility purposes so that you don't need to come up with unique names. Now, as we've learned about hints and labels, let's touch on validation. Because the way that we surface errors and validate user input can have tremendous impact on user experience. Let's see how we can implement it. To indicate mistakes, we use red border and display an icon. But similar to how we have this visual cue, we need to provide semantic cue as well. We can use another ARIA attribute here called area invalid. And when set to true, this information will be surfaced in the accessibility tree and communicated to the user. One handy tip in here is that we can actually use all of these ARIA attributes for styling purposes as well. I really like this approach because it is easier, you don't need additional CSS class, but also it is more reliable because it makes sure that your visual cues and your semantic cues are always in sync. Now, as we mark input is invalid, we also need to communicate an error message as well. We can do it the same way that we did with the hints before by using accessible description. Area described by can actually accept multiple IDs, and then we'll concatenate those messages together when announcing to the user.
Username, invalid data, edit text. This username is taken.
So now when looking at the inputs, we learned about labeling, using ARIA, useID hook, and also using ARIA to expose validation errors. Let's now cover our last example, which is notifications, and how to implement them accessibly. Notifications in visual UI kind of come naturally. We can't just display a message on the screen, and the more important the message is, the more visually prominent it becomes. Because something changes on the screen, you immediately notice it. However, screen reader works sequentially, so it cannot be focused in several places at once. So we need a different way of notifying users of assistive technology. This brings me to ARIA Live regions, which is another really important and powerful feature of ARIA that allows us to define certain places within the page as live. And then they will be watched. And if something changes within that place, then screen reader will get notified and can announce this change to the user without losing its current position. We can set it with ARIA Live attribute, which can be set to polite, meaning that it will wait for current speech before announcing the change, or it can be assertive, meaning that it will interrupt the speech for the announcement. To use it for our notification, we can set it ARIA Live attribute on the message, which will convert our notification into a live region. Alternatively, we can also use role status. This is a role specifically designed for messages like this one, and under the hood, it will set ARIA Live to polite, along with ARIA atomic property, which will make sure that the whole message always gets announced implicitly. And now the user can get notified like this.
Delete button. Item was deleted.
We can use the same approach for communicating errors as well, like here. To use it, we can again set ARIA Live polite to assertive on our error message, or we can use role alert, which was specifically designed for important alerts like this one, which will set ARIA to assertive under the hood. Now our error will be communicated like this.
Sign in button. Sign in failed. Username or password are incorrect.
So when talking about notifications, we learned about live regions and live roles like status and alert that help us notify users about important updates. However, when using these features, it's important to be cautious, because if overused, they can also create a really distracting and frustrating experience for the users. And this is the last example that I wanted to cover. And as the last thing, I want to note that accessibility is not black and white. And by learning more and making small improvements, we can generally move towards a more accessible and inclusive web for everybody. And there's only so much that I can cover in a lightning talk. So you can follow this QR code to get more details about testing accessibility, some tools to dive deeper into these topics. And I hope you got inspired to make accessibility a bigger part of your workflow. And happy Global Accessibility Awareness Day. Thank you.
My Catherine and everyone, thank you so much. All right, so we're gonna prime up for our next speaker. That was actually a wonderful lighting talk. Our next speaker is gonna be hailing in from France. So the land of croissants and Napoleons, like I mentioned, that I love very, very, very much. I was actually conversing with some of y'all on how pedantic I get at like, that's a great way to test if you find like a pastry shop and like really test to see if your other pastries are gonna be as great, is how well they execute on Napoleon. Another pro tip, I'm gonna get back to it, but like for food, another test that I do, if a place has really good chicken wings, because I get that a lot, like, oh my God, this chicken wing is fire. I'm like, all right, let's see how well it holds up, is to just order chicken wings, not breaded, not sauced, sauce on the side. It could be seasoned or spiced, but depending on how well, you can tell if they marinate and season their chicken wings before they fry it or put it in sauce, which is a great signal for telling you if that place actually has really fire chicken wings. Anyways, our next speaker, like I mentioned, was coming in from France, and they're representing the French flag as well as the Italian flag. They're a really playful and joyful person, and they have a really knack for and drive for just excellence in software. So I'm really excited to see what they're presenting. Let's give it a huge welcome and shout out for our next guest, Olivier Tassinari.
All right. Hi, everyone. I'm so excited to be here. And today, I'm not going to talk about your favorite topic, or maybe not, CSS in JS. By the end of this presentation, I would like you to better understand how React server components are shaking the space, how the challenges are with the current generation of library in this space, and some of the key properties I think you should look out from a great styling solution. Now, the space may be shaken, but there's hope. I'm also going to introduce Pigment CSS, which I believe in this part of this next generation of CSS in JS libraries. And let's start into it. So I would like to start with 2 quick questions for the audience. So please raise your hands. Who here is currently depending on emotion or style components? Whew, OK, so I see maybe 50%, 45% of the audience, maybe a little less. And a spicier, well, hold on. So you guys seem to be a good sample of the ecosystem. So if you look at the last State of CSS survey, you will find that about 50, 60% of the ecosystem actually also depend on these libraries like you. And no, last question, and a spicier one. Who here feels left behind by these libraries and is considering migrating away? So please, again, raise your hands. Maybe I see half of the people that raised their hand initially. So if you look at the same survey, you also find that since a year or 2 years ago, has been an ongoing decline in interest in style component and emotion. And on the opposite side of the spectrum, you'll find maybe, for instance, CSS modules that grew in interest. So what is going on here, right? So I won't be able to give you a definitive answer, but at MUI, we have experienced similar challenges. And so for those that don't know me, I'm Olivier, and I co-created Material UI a long time ago, and I'm now running MUI as its CEO. And so how is this relevant? So at MUI, we maintain a few open source projects. You will find Base UI, which is a library of headless components, meaning unstyled. Then you will find Material UI, which is a popular UI library extending Base UI that implement material design principles. And on top of these two, we have MUX, which brings advanced components like data grid charts, dat picker, and so on. And lastly, we have Toolpad, which is a set of components to quickly build internal tools. So how is this relevant? So the common denominator between all of these projects, one way or another, for instance, in Base UI, when you use emotion for the docs, is the reliance on emotion. And that gives us a good exposure to the problem. So the first thing you're going to see is bundle size. So when you install style components, you subscribe by default to 11 kilobytes of JavaScript, plus 4 or 5, depending on the theme object that you need to carry around in your application. So in total, it's like 60 kilobytes, which is about a third of the bundle size of React in the bundle. So it's not the end of the world, but you still have to ask yourself, is this really needed? Like, do I need to carry this around? And the second one performance issue, I think this one is a larger hit, is with the runtime impact. So here you can see the time it takes to render 1,000 rows of table with CSS modules, Material UI v4, and Material UI v5. And you can see that in v5, we use emotion. In v4, we use GSS, and CSS module is much faster. There's like a significant cost here. So you can't really effectively use emotion without virtualization for these use cases. Now, let's say you still add virtualization. This is our data grid rendering 100,000 rows with CPU throttling enabled. You can still see blank screens. So what's going on here, right? So if you look at the flame graph or like the timeline performance, you will find that about 14% of the time is spent rendering again and again and generating the same emotion styles. And so in theory, you could have 15% less blank screens. And I think if you use these components for analytic use cases, that matters. You really want to solve that. And if that wasn't enough, also hear this from you. Here's a user that is loving to use the ESX props, but is struggling with the performance of it. So that was for performance. The more recent challenge is with the React Server components, where today nor emotion or style components are compatible with it. And the key blocker for them is the context API that is not available on the server, or maybe, I don't know, yet, or maybe ever. And there's also a possible workaround with the cache API, but we don't really see movement happening there, so we are stuck there. So this problem feels too important for us not to do something about it. And this is what we started to do at MUI about a year ago. And I would like to cover how we approach this. So the first thing you could do is look at solutions, but there is an overwhelming amount of them. You'll find inline style CSS modules, Stylix, Tailwind CSS, Linaria, Panda CSS, and so on. So what we can do on the other side is just look at the key properties I think we should have, right? But before I dive in, I would like to raise a disclaimer. So I'm looking at those from the perspective of my own context and the perspective of Material UI. So these solutions have trade-offs, and they have contexts where they are best. So the very first thing I think we need is style collocation, meaning having the style in the same file as the HTML. And I think that this brings great benefit. It minimizes context shifting. You don't have to name everything. And it also means that because the things are more closely related in the same file, you have access to more dynamic logic with JavaScript. And for those that truly want separation of concerns, they can still do it. Like it's not the end of the day. They can move this to a separate file. So in that context, CSS modules isn't that great, so it would be great if we don't have to use it. And I think for me, like a second key dimension to look at is, are you going to use atomic classes or not? So lately, we have seen a merge, and a trend of more atomic classes-based solution emerging in the ecosystem. And these are very interesting because it means that for small and medium-sized application, you can keep a single CSS file without while keeping the performance fast enough. And this is really much simpler. No, it's not all bright. I feel like you also have a cons and the downside with the debugging experience. So here, for instance, you can see that in the dev tool, on the right side, you might see style are heavy to look at, and on the left side, a DOM that is also harder to inspect. So for me, the best user experience was the one we used to have in Material UI v4, where we could simply look at the DOM and see very clearly how the style are structured and inherits. And then from there, you can customize. So I talked about medium-sized application, but what about large one? So I think atomic classes works for large application as well, but as a very significant condition, which is you don't use nested selectors, or at least you use and you keep them very much in check, otherwise it completely breaks down. But I believe nested selectors have nice use cases, so I want to still be able to use them at scale. So to scale the application, I believe that even with atomic classes, you need to have granular style loading. And what I mean by this is only loading the CSS of the component that are on the page. But once you get granular style loading, do you still need atomic classes as much, right? So you don't really have to trust me. You can also trust Sebastian Markbeg, which is the former React tech lead on the team. And here's a quote highlighting the need for why you need granular style loading. You can rewatch this after my talk. So if you look at the space here, there's basically two kinds of solutions. I think if you look at emotion style components, CSS modules, Linaria, they are great story in terms of code splitting. But if you look at the more recent atomic classes solution emerging, it's harder. At least today, they don't have this built in. And I think for me, another key dimension is familiarity. Do I have to learn a new API? Or can I rely on my existing CSS knowledge? I don't want to have to learn a cheat sheet. Maybe I'm a designer, or maybe have limited bandwidth in my memory. So, and the last dimension for us, I think, has been the most, let's say, structuring has been backward compatibility. We've experienced firsthand when moving from GSS to Emotion in V5, how painful it was for the community to migrate. So what if the solution we were coming for only had to replace imports? Wouldn't that be amazing? And I think, honestly, the style components is just fine. So what do we do from there? I think this is where Pigment CSS steps in. It's a new CSS in JS library that we have been working at MUI for the last 12 months. No, I know what you're thinking. Oops, sorry. Not need the audio.
You're joking. Not another one? Oh,
right?
for God's sake, I can't honestly.
There's so many of these. So why are we doing this, right? Like, couldn't we just use an existing libraries? And maybe not, we'll see. So I think what's very interesting for us to do is map the space. If you take on one side how costly the migration is, and on the other side axis, you plot how much we rely on a bundler and how much we are close to CSS, you will probably find this space. And like that's what happening, how the solution like already displays themselves. So today, if you start from Emotion, which I think a huge chunk of the community is at, you effectively have two possible directions to take. You can either go into the CSS modules or the Tailwind CSS path at the cost of a costly migration, and you have to give up on some of the properties I talked about before, so either style collocation or granular style loading. Or you can go the other direction and go with the more recent library like Stylix or Panda CSS and more older Linaria. But then you still have these costly migrations, and they usually also don't go as much as they could into like a deep bundler integration. So our thought was, and you've seen this released yesterday with the React compiler that opens the door for deeper bundler integration. What if we were actually to go down that path of up to Rust integration? Wouldn't that be kind of something that would deliver? And we haven't seen anyone going there. So that has been our trade-off and our bet with Pigment CSS is what will happen if we actually go and explore that space. And so if you add Pigment CSS to the chart, that's where it lands more or less. So how does it look like? Well, it's pretty much the same as Emotion. You might find an extra property feature, which is the SX prop that works on also native elements, which I think is very interesting when you really want to quickly iterate and prototype. Some of the key design decisions we have there, we wanted to have no runtime, but still with a fallback because we didn't want it to be stuck if the bundler integration is not available. React server-side component support, granular style loading, as few breaking changes as possible, and still be able to use atomic classes later down the road once we nail the atomic, the code splitting aspect of it. Now, if you look at performance, this is what we had before, and this is how it looks like once you compare it to Pigment CSS. It's very close to CSS module, and the Material UI v6 is what we expect as performance comparing to the previous one. So as you can see, it's about 2 times faster than the previous version. So I'm pretty excited about this. Now, how does it work under the hood? So very quickly, it starts as a fork of Linaria that we have extracted the logic into what you want in GS, which is basically a way to share the effort into the bundler integration. And it effectively transpiled to CSS modules files. And to finish the presentation, so when does this land? It's still in alpha at this stage. Some of us have already been experimenting with this, like Josh. But we're pretty much focused on making this available as an opt-in feature into Material UI v6, where in v6, because it hasn't been a new major version for 3 years now almost, has been mostly about modernizing the stack, like for instance, updating browser supports and so on. So that's about it for my talk, I think. So you can find a blog post that introduces this. And if I could like leave you with only one note, would be, what if we could make CSS loading pre-shaking as important and as emphasized as we do it for JavaScript? I think that would be amazing. And if I could just translate that knowledge and information like vision, that would be great. So please give it a try and see you next time. La pote?
Merci, Olivier. Amazing.
Merci, Ashley.
All right, I'm excited because I have another opportunity to share a little bit of Haitian history with y'all and a little bit of my culture for Haitian History Month. So bear with me. So another reason why I'm really excited about this is that during the Haitian Revolution, right, it was something that was very brutal and very violent, and I'm not going to go into detail to keep this PG-13. But throughout all the violence, and especially once the Haitians finally gained their independence and started to push a lot of these settlers and colonizers out, emerged a very unsuspecting ally, and these are the Polish. The Polish understood from multiple invasions by the Russians, Prussians, Austrians, the empathy that the Haitians were experiencing, and they empathized with the suffering that the Haitians were experiencing and aligned with them and actually helped them throughout the revolution. So I'm really excited to announce and welcome our next guest speaker, Mikhail, who will be introducing us on, you know what, I'm not even gonna dive into that, but please help me give a huge welcome and an exciting round of applause for Mikhail.
Thank you. Oh. All right, hello. I'm not gonna wear it all the time. How's the React Conf going? Okay. So, give me a second. I actually need my glasses. Yeah, now I can see you, although not in all those bright lights. So, yeah, let's go. How many of you tried the Apple Vision Pro yet? Yeah, that's a lot of hands. You can still try it at the Colstack's booth. It's a kind of a unique experience. You have to try it. While I'm speaking about Apple Vision Pro, it's because a year ago, Apple announced this new device and the new era of what they call spatial computing. And I gotta say, I got quite excited by this device, although because I'm not from US, I'm from Poland, Europe, it's not available there, so it was quite a hassle to get one. I was like very excited about it, and I immediately thought on, hey, I would like to spatial compute with React. Wouldn't that be amazing? So I think React is very well positioned to run on this new thing because it's if you tried React and React Native, you probably feel that it's like a universal language for building apps. And it's not only available for over 10 platforms, it's also used by 4 million developers. And I think like around 1/10 of them probably know React Native and is able to ship something not only for the web, but also for mobile, for desktop, for TV, and for VR devices. So once you learn to think in React, and you also learn React Native, it tricks with you a bit because if you shipped for N platforms, why wouldn't you be able to ship for N+1? However, will it prove to be productive on this new thing? Because spatial apps are quite different. We don't have the mouse, keyboard, or touch devices. We have hand gestures and some advanced eye tracking. We don't sit in front of a screen. We're sitting like immersed in multiple screens at the same time. And what's even more interesting is that those screens can bleed some extra content before, after them, and all the space around. They immerse in the space that you're seeing. So let's see how Apple is thinking about developing apps for this new device. Apple tells developers that this is the Swift UI, you know it already. You could ship your apps for iOS, for iPad, and any other Apple platform for years now. And this is what you work with for this new device. And this is, you can see this is like a declarative language. You see some definitions for stack, for 3D model, for text. This looks kind of like React to me already. And frankly, we didn't need Apple to tell us that declarative programming is a way to go for rendering 3D in 2D or 3D environments. Projects like React Free Fiber, and shout out to the maintainer here. Woo! Show us for years that React is capable of doing that with custom renderers, just rendering mostly for web, but it's also available for mobile with Expo GL. So let's go back to the Vision OS, which is the operating system powering Apple Vision Pro. There are two ways of running apps there, the native way and the compatibility mode. So as you can see, on the right, we have the, on your right, yeah. We have the app displayed in compatibility mode, and it feels slightly off. Like, it doesn't have the translucent background. It resizes together with the text, not together with the layout. And the error messages, like for alerts, feel flat and just off on that platform. They don't provide this extra depth as a native one. And not to mention, you can't interact with the new goodies like the immersive spaces experience. So what you can do is that you can fork React Native, because this is this project that gets React to any other platform. So this is exactly what we did. And yeah, React Native for iOS is written in Objective-C. You don't need to understand that. In fact, we can actually comment out that code, and the errors that were happening are going away. So yeah, software development sometimes is easy, isn't it? But if you know Objective-C, if you know C language, please don't get mad at me. We added if-defs, which is like a proper commenting if-branching technique for the C languages to make it right. And after some fiddling with that, we got something on our screens. We rendered a native app with React Native, and we got a runtime error, which is expected to do. We wanted to see that beautiful red screen co-designed or designed by Ricky, if I remember that, or redesigned later to look how it looks slightly better than this one. So is it like now that we have it, now that we have this app rendered for this new platform, we can actually verify if we're able to create the user experience and the actual developer experience that's suitable for writing apps in a productive way. So firstly, we would like to focus on hand tracking and hand gestures and eye tracking. And because React Native just uses the platform, we got that mostly for free, especially around hand tracking and the gestures there. And for eye tracking, we needed to add extra API or implement a specific Apple's API for the view element. And at the same time, we've seen some great work on the web compatibility from the React XPlat/Convergence team. And also, we've seen similar efforts from macOS team at Microsoft, which those two teams wanted to find a better way to abstract the pointer devices, pointer events. So we went with web specification. So today you can just use cursor pointer that you know from the web, and it just works. You can look at the icons here, and they are highlighting. This is the hover effect. And what's more, this is now compatible with this enabled this experience not only for Vision OS but also for iPad and for macOS. Another thing that we needed to tackle is multi-window support, because those Vision OS spatial apps usually work they work really nicely when we have multiple windows surrounding us. So they don't have to be separate apps. It can be the same app. However, it's not the same as just opening another tab in your browser, because in this case, we are sharing the JavaScript thread. It's just we're running second window in another React root, so they don't clash with each other. And to do that, we needed to adjust some internals in React Native that were using the screen, and some they were just assuming that we only have like one screen. So we adjusted that, and we introduced the Window Manager API, which we actually co-developed and designed with the native script team, which at the time was also working on adding VisionOS support to their framework. And this work is designed to be, this API is designed to be compatible with Windows, with macOS, with iPadOS, and probably some other platforms out there. And the last thing that we wanted to tackle is the immersive content experience or experiences and environment, as Apple calls them. So to do that, we implemented the XR, standing for Extended Reality API, which is actually modeled on the web specification for XR session. So you can request the session, you can close it, and you pass the control to the native layer. So in this case, we can see the 3D 3D space that's completely designed in Swift, and it's controlled by Swift. So let's have a little demo time, okay? And let me drink some water. So I wanted to do this demo on this headset, so you could see yourself with all the screens surrounding me and you. However, mirroring on this internet sucks. So I went with the actual simulator, and I will say that Apple made an amazing job with the simulator, because we developed all those things without having access to the device. So let's start with an iOS app that we designed here. So this is a regular app with a list. You can open another screen in a stack. It uses React navigation, so it's a native navigation experience, and that's about it. However, for VisionOS, this is different. It's the same code base, but adjusted for the new platform. So you don't see like white or black background. We have the translucent background. We have the same. We have the same list. We can hover over it, and it lags a bit right now. But you can see I'm hovering with the mouse. Normally, it's simulating me looking at this thing. It feels really nice when you have this headset. So you gotta try it yourself, and you can click on this thingy, and yeah, this is a live demo, and it doesn't want me to click. So maybe, yeah, it's for my Mac, it's probably too much to handle screen mirroring and showing the demo. However, what I wanted to show you in this example, I have some fallback, no worries, is that you can adjust your code live as you go, and play with the edit it as any other React Native app or React app having access to fast refresh. You can adjust the mirroring, you can adjust the hover experience, and yeah, let's maybe go for how it looks like in the real environment. So this is the hotel that you can probably see. This is the same app, just rendered for the production environment. And what we see here is that we're opening a element. We're opening in a new window. It's loading the 3D element. And what's cool with that is we're rotating this 3D element. It's all powered by JavaScript with React Native Gesture Handler and React Native Reanimated. So it's fully 3D, fully JavaScript controlled. And what we entered here is the immersive space that's rendered with Swift. This is designed in the Spatial Composer, which is an app from Apple. And I'm going to show this to you, actually. So you can see this. I'm entering Xcode. And this is the space. So it's almost the same as you've seen. The only missing thing is that this character here, because it's added dynamically to the scene so that you can animate it. And you can see this is the Swift UI code. We have handling gestures for dragging this character, and we can interact with it, although this is solely on the native side. And this is actually a beautiful thing about React Native, because if we don't have something designed or created with JavaScript yet, we can always dive into the native layer and just use the platform. And we're also working on a implementation for like a next step for that, so you could control the scene from JavaScript and control the gestures for that as well. So sorry about the live demo not working, but please. It's like working with any other app. It's just my Mac is not too powerful to handle that with the screen mirroring. So yeah, for us, working on React Native for Vision OS, it was a really rewarding experience, and we felt like React and React Native are great platforms and great tools to build experiences like that, to build new platforms for developers to enter and ship their apps. And I think a true testament to that is that we shipped the official version of React Native Vision OS at the same day this device was available for anyone to buy. Same day, day one. Thank you, React. And you can start with this today. You can create your next React Native, next Apple Vision Pro app with React Native using a single command. You can scan this code. It will direct you to the project's repository. Of course, it's open source. We're working in the open from the very, very first interactions that we've built. And we can't wait for you to try it, to file bug reports, and hopefully contribute some documentation and code maybe if you like it. And I wanted to also mention that actually we don't know if this device is going to be any successful. So we wanted to make sure that our work is elevating the community and improving the tools that allowed us to build that in the first place. So we contributed back whatever we could. We contributed code, new APIs. We made some more web-compatible APIs for core of React Native. We contributed to macOS, to React Native for macOS, for tvOS. We contributed to Hermes and many other community libraries to make it happen. And it was a very pleasant experience working with this community, making it happen. So thank you everyone. I know that some of you working with this platform are also, and especially people that made it possible, are on the stage. So thank you very much. Yeah. Sorry for taking it slightly longer. Last but not least, I want to thank the two people that are core contributors to this project. Oscar, who is actually shipping the code, and he's working in CallStack's R&D, and Matt, who is our technical guidance in the extended reality world. And that's it. Thank you very much. It's been a pleasure to stand here.
We're now at break time. Feel free to now take a quick walk, relax, unwind, and decompress for the next session. Thank you so much. Say this again for the folks online. Mic check, check. Mic check. Mic check. Mic check. Do I keep it for now or? Am I still live or? Am I still live for online or? Yeah. Are we still streaming? Because I just wanted to at least let the folks know online. Okay, cool. Is there a mic here? Mic check. Oh, okay, there's a mic here. All right, cool. Let's go for emergencies. All right, so for those of you online, we're going on break. We should be back in like 3:30 PST. Thank you so much for tuning in. I'll see you in a bit. Hey, guys, so sorry about that.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Mic check, check. Would everyone please take your seats? The conference is about to resume. Thank you. So, we're gonna do a little activity, nothing too crazy. We're gonna clap together. Let's do a nice slow clap, and then when I get to raise my hand, I want everyone to start screaming, shouting, yelling, praising, all the stuff, and bring out the good vibes. Are you ready? All right, on me. All right, so we're gonna pick it up with our next speaker, and if you talk to them about anything fruit related, they will light up like a gem. I personally, my favorite fruits are mango and papaya, but once we started that, we went down several different countries. She'll tell you exactly which country to get the perfect and sweetest mango, but I digress. Let's all give a nice and huge warm welcome to Aurora Sharf.
Thank you for that introduction, Ashley, and thank you, ReactConf, for having me here. Hold on, just gonna unlock my screen here. So my name is Aurora. I'm a web developer coming all the way from Norway, and I work as a consultant at in Meta in Oslo. And that's not Meta, but in Meta, which is funny now, being surrounded here by all these Meta people. But anyway, I'm excited to be speaking today to teach you how to enhance your forms with React Server Components. And I'm going to be coding a simplified version of something that I've built for my current consultancy project, where I'm actively using RC, and it's working well for us. So let's look at the setup here. So I'm here in a message box component, which is an async server component, and it's asynchronously fetching data from the, excuse me, let me just present my setup first. This is now the Next.js app router, and I'm using Prisma as an ORM and a local database using SQLite and Tailwind. So the message box component is a server component and is async because it's asynchronously fetching data from the database with Prisma here. And it's mapping these to individual message display components. And this is also a server component because it's essentially just showing some UI here based on whether the user has written the message. And then there is a message input. And this is just a form that doesn't do anything. And I can just try it out. Doesn't do anything. So let's enhance this with React Server Components and React 19. And the goal will be to make this interactive while reducing the front-end complexity and minimizing the JS on the client. So let's start by making this form work. So I'm going to use React 19's extension of the form element to bind this to a server action. Excuse me, submit message. And this could be an action on the client, but since we're using server components, we can use a server action here. I'm going to make a new file for this. And this is going to be a server action, so we need the use server directive. And this essentially means that this function can now be called from anywhere, like from a client component, because it has a hidden post endpoint generated. So I'm going to export an async function called submit message. And it will take in a form data object here of type form data. And what this means is that each field inside this form will be submitted with its value in this form data. Yeah, pretty much that's it. And we can use that to submit to the database. So I'm going to create a message in the database with some data. And this is going to be have a content, which, let's do that later, which we can get the content value from the form data. I'm going to type this as a string for now. And then we need to pass a created by ID here to know who has created the message. So I need to pass additional arguments to my server action here. And there's a couple ways you can do this. You could do a .bind on a function to pass initial arguments to a function. Or you can use a hidden input field. So I'm going to do that here. And I'm just going to call it user ID. And now I will have this inside my form data object. So I'm just going to close this off and save and import my submit message server action. And let's see what happens now when I try to submit this form. And then refresh the page, and it's been submitted. But I don't want to manually refresh the page. So I'm going to use Next.js revalidate path to tell Next.js to purge the server component cache and regenerate this server component. And now let's try. Going to say hey, and now it's submitting and updating the UI on its own. So just by doing that, I have now bound this form to an action, and this can, without JavaScript, call the server action and query or insert in my database. So if you remember Sam's talk yesterday, he had this initial setup of, excuse me, I'm going to reference that later. Anyway, but if I had used the onSubmit here, I would have had to wait for React to hydrate this form to be able to submit to the database. Where I'm using the action, I don't have to wait for that. But the scroll bar was like here after I submitted, and I would like it to automatically be at the bottom. So I'm going to go to my message box component here and replace the div with an automatic scroller. And this is a client component because it's using an effect to, with a mutation observer, listen for mutation events and automatically scroll to the bottom of the container. And this is a client component, but since it has the children property, or it could be any name, but I'm using the children property, this will now wrap server components. So I'm still rendering server components inside the automatic scroller. So let's just see if it works. It's scrolling to the bottom. And I can also look inside the DevTools here and see that there is no message display in this DevTools because that's still a server component, and only the automatic scroller is a client component. Yeah, this is messed up now. Is that OK? Yeah. So if I head back to my message input and the submit message server action, I've been typing this as strings. But I don't really want to do that because this is essentially untrusted input. I have no idea what's coming from the client here. So I'm going to use a runtime validator like Zod for that. And it will, at runtime, check that my data is of the type that I'm expecting it to be. So I'm going to get a result from that, and I'm going to say message schema, and I'm going to safely parse an object and move my object inside this. And then I can use the result to insert into my database. And then I need to handle the case where my validation failed. So if it's not a success, throw an error. I'm just going to say invalid message data here. So when I now comment out my client-side validation here and try to click the button, I will get an error. And you can handle that however you want, for example, with an error boundary. So I'm going to add an error boundary around the message input. And wrap that, and it just has a fallback saying something went wrong. So now when I click this, not like that, with an empty invalid message here, the error boundary will render it for me. But I don't actually want to throw an error here. I would rather return something. So I'm going to return an object with a success flag and an error. And I can just say invalid message data, something like that. And a timestamp. And I'm going to need this later, and you will see why. So I'm going to make this timestamp. And if you, for example, want to server-side validate per field, you can also return the per field errors here and display those from the server. But I just have a single field. I don't need that here. And maybe you want to do something else on the server. Maybe you want to check that a user exists, query the database, something like that. So I'm going to get the messages for the current user and limit the amount of messages the user can send. So I'm going to say messages for user. And I have my getMessages function here. I'm going to reuse that with the user ID. And if this now is, let's say, over 5, we'll return an error, user has reached the message limit. And then I can insert it into my database. And in the case that this fails, I'll just let my error boundary handle that problem. And finally, I can return success true. So now I have some server-side logic here, and I need to get this to the message input component and to the user somehow. And I can do that with the React 19 hook, use action state. Use action state. And it will take in a action or a function to call. And we're going to put the submit message there. And an initial state. And I'm just going to say success, false. False. And this use action state can now return a generated component state, which will be equal to first the initial state, and then after the last return value of use action state, of the function inside use action state. And then it will return a wrapped action to call, and by convention, you should call that submit message action. And I can put this on my form and use the state to display the error that the server is returning. Like that. And I have a couple problems still. First of all, this is now using a hook. And if you're going to use a hook, you need to tell the bundler that it should load the JS on the client for this. So I'm going to say use client. And I still have to fix an error here, because when you use action state, the action that is wrapping will receive an extra argument called, or it's a previous state. I'm going to call it previous state here. But I don't need that right now. I'm going to make a type for that really quickly. Oops. And the function will now return a promise of that state. And I've already made this state, so you don't, or this type, so you don't have to watch that. So now let's see what happens. So it's still working here, hey, hey, and then when I hit my max message count, the error can be rendered in the component. So yes. But I want to make this a little bit more interactive and not just render some text here. So instead of doing that, I'm going to use an effect to listen for the state change here. And if the state has an error, I'm going to do toast with this error. Excuse me, and this. And then I need the dependency array here, if I can type my curly brackets, which I'm not able to right now. There we go. And we also need it to depend on the timestamp so that it will rerun whenever the timestamp changes. I'm going to say state.timestamp. And let's just try it out. Hi, this time. And I get a toast now. So I don't actually need this span anymore, but instead of removing it, I can leave it as a no script fallback, so that if there is no JavaScript, I will still be able to see the error from the server. So now I only get a toast here. Yeah. Let's see, what's next? But when I'm submitting here and it's failing, my form is being cleared. And the reason for that is that with React 19, when you use an action and uncontrolled inputs, they will automatically be reset by React. And this is good because it kind of copies the MPA form submission behavior. And maybe you're used to using like reactive form, which essentially is making a like controlled component form state, controlled form state. This is now just using an uncontrolled input, and we don't need to put any state for the value here. But maybe the user could have changed this input to make it submit, depending on the validation. So let's return also this value from the submit message function here, and just return the value that has been submitted. And what we can do is leave this as the default value of the input, so that if there's an error, it will be here the default value. So now when I say, hey, it won't be cleared for this error. And still, there's something to improve here because I'm using a local database and it's responding quickly, but in reality, when you do the round trip to the server and back, this could take a while. It could be kind of slow. So now when I click, I don't see any feedback right away. And maybe I'm like inputting something and it's not sending. I would be sending multiple by accident. But luckily, the use action state also returns a is pending, or a value that is equal to the pending state of the action that is wrapping. So now I can use this pending state, or pending Boolean, to disable my button. And maybe say something else here, like is pending sending. So let's just try that out. Now it's saying sending, being disabled as the server is, as we're waiting for the server here. And let me just increase the max messages here to 8 and try the non-failing version again. So it's sending, it's scrolling, resetting the form. And if you remember Sam's talk from yesterday when he was like doing this whole thing with, in the initial version of his code, with setting pending states and error states and all of that, the use action hook just simplifies that for me and handles everything. So this whole form actually works without JavaScript. So let's look at that for a second. So I'm going to just disable the JavaScript here and try it out. And it worked. I'm not getting the automatic scrolling. I'm not getting the feedback on the button. And I'm getting a full page refresh. But it's still fully functional. So let's just see that again. It's working. And one more time. Oops. And then I hit my max message count. And the no script fallback is rendered instead. So what we... Oh, yeah. You can clap for that. So what we've essentially been doing here is progressively enhancing this form, meaning ensuring all the basic functionality works and then adding things on top to increase the user experience or enhance the user experience for the users with these additional resources available. So let's say the user is on a slow device and is waiting for JavaScript to download, parse, execute, whatever. Could take a while. This form will now work before JavaScript is loaded and will ensure the hydration of the JS that we do want loads faster because we're weaving the server and the client together by using this automatic scroller. Yeah. Hold on. So now, depending on the user situation, they will get a better user experience and always have a form that works. And if you don't have to write progressively enhanced forms. Depending on your product or whatever you're building, you can consider it and still use your React form and use server actions with that. That's all possible. But by using these more primitive features of the form component with React 19 and React Server components, we're able to do this now, which hasn't been so easy in React before. Unless maybe you were using Remix, in which case, good for you. But I actually have some more to show here, because I've been progressively enhancing this further. So let me just get rid of my code here and jump over to optimistic branch. Oops. And in this branch, I've not done a whole lot of changes, but I've made a messages component that's taking in messages from the server. And it's a use client component because it's using the React 19 hook use optimistic. And this hook will take in the state to show when no action is pending, which is the server messages. And it will define a update function, which is how the optimistic state is going to be updated. And the optimistic messages have an is sending true here. And this is pretty much the same, and I'm passing in my update function. And in the message input, I've added a onSubmit, so that if everything is well and hydration has completed, we can call the onSubmit instead of the action, and the action will function as a fallback. So now I'm inside the onSubmit, doing some stuff to reserve the progressive enhancement, and then adding the optimistic message with the data, and then awaiting the actual function or the actual action to update on the server. So let's see how that works. You can say, hey, hi, test. And as they're in their optimistic state, they resolve from the server with the truth, kind of. Once more, hi. So we get the optimistic first, and then the server state. And then I can keep going and keep sending until I hit my max message count, where the state from the server doesn't match my optimistic state, and it's automatically rolled back. Woo, right? And when it's failed, it's also rolling back here. So that's pretty much it for the demo. I hope you get excited about this stuff as well, like me. And the code for this is on my GitHub if you want to look at it. The optimistic update is in a branch. And thank you, ReactConf, for having me. Thank you.
Big ups to the demo gods. All right, we have a nice duo coming on right now. They're making their their debut at ReactConf. It's a really awesome team. I've had a fun pleasure to vibe out with them. So, before we dive in, I wanted to see if y'all remember something. Honor. All right, some of y'all got it. Let's do that again because I ain't about it. Honor. There we go. All right, let's shout out and give some good respect to our upcoming speakers. We have Naman Goel, as well as Olga. Olga is coming in from Uzbekistan, and Naman is representing India. So let's give them a huge, warm welcome and a round of applause.
Oh my God, I am so excited to be up here on this stage at my first React Conf, seeing sort of all of your bright, excited faces and maybe a little sleepy like back there, but it's okay. It's the end of the day, I understand. But I'm especially excited to tell you all about one of my favorite topics, which is cross-platform React. But before we do that, let's go back in time and review how the story started. Imagine you are at React Conf 2015, and I know some of you were there, so you can keep me honest. So by this point, React is already pretty popular. Introduced just 2 years earlier, it had demonstrated the power of a declarative UI programming model. React was awesome for building UIs in the web. But this is 2015, and native mobile apps are becoming increasingly more important. Of course, you can write a React web app and ship it on native with a wrapper, but that comes with some downsides. Performance is probably worse. User interactions don't feel quite right, and the app just doesn't really look and feel right on the native platform. But native development was challenging in its own way. You have to staff 2 full teams of iOS and Android engineers to maintain 2 separate code bases and 2 separate infra stacks. It's just really expensive. So it's against the backdrop of this that React Native was introduced, promising to combine the power and performance of native development with the intuitive UI declarative programming model of React. It presented a vision for building UIs across platforms without having to learn platform-specific tech stacks. We weren't aiming for a single shared code base, but rather a consistent programming model. It wasn't write once, run anywhere, but learn once, write anywhere. So Meta thought this is a pretty compelling approach to native app development, and we have since shipped React native experiences across a broad range of our own first-party apps. And many others thought so as well. As you saw in the keynote earlier today, the React Native community is large and continues to grow. And many companies, from tiny startups to large corporations, have come to rely on React Native to create their most important user experiences. In addition, since its initial release on mobile, React Native has scaled to many additional platforms. You heard about some of them earlier today during the Amazon talk. Of course, there's also macOS and Windows, originally created by Microsoft, where we still have a very strong partnership with them, and most recently, VR. This has continued to confirm that the React programming model is a compelling way to develop user interfaces anywhere. So we must be done, and React Native is perfect and cannot be improved, right? And I can probably just walk off the stage and give you some time back. I know you want to go home, but we still have another 15 minutes to go. And unfortunately, we're maybe not quite done yet. So you've heard over the past couple of days about many improvements made to React Native over the years, including a major redesign called the new architecture, which addressed some fundamental limitations of the original design. But there's something else limiting the potential of React Native. During the keynote earlier today, you heard about the Meta Quest Store, which is a cross-platform app that is available on mobile, web, and VR. Now, if this experience weren't built using React, you would need 4 separate teams of iOS, Android, VR, and web engineers maintaining 4 separate code bases and 4 separate infra stacks. So your development costs would scale linearly with each new platform. Having this experience being built with React across these platforms means that engineers can move between them more easily. You can share more of the infra and business logic code. And the cost of development scales much better than linear. But we should be able to do even better. Because today, none of the web and native UI code for these experiences is actually shared. And while the UI isn't identical, the design language is really similar, and the structure of the apps is almost the same. There are a lot of common shared components. We don't want to get to 100% code sharing, because experiences should look and feel custom to each platform. But what we found at Meta is that teams often spend the bulk of their time on repetitive re-implementation work, and then they don't have as much time on actual customizations that make the experience feel really bespoke to each platform. So what's stopping people from sharing UI code easily today? Well, the original design of React Native was all about taking inspiration from the best of the web. But taking inspiration meant diverging, sometimes intentionally and sometimes incidentally from the standard. And what you got was an API that felt and looked similar, but behaved differently and was different in very subtle and sometimes unexpected ways. What you got was essentially one more standard. And this standard proved to be the barrier between code sharing between web and native. Now, there have actually been solutions built for solving this. Some of you may be familiar with React Native for web. If you have used Expo and shipped your experience on the web, you've used React Native for web. It's a user space library designed to let you run React Native code on the web. Very popular, but it's built on top of the same non-standard React Native API, which means that it has to do a lot of work to bridge between that API and the web API, which means performance compromises on web. It also forces web experiences into using the React Native API, which is less natural and expressive for web development. So what if, instead of building solutions on top of React Native, we considered a more fundamental change to React Native itself? What if, instead of being simply inspired by web the good parts, we moved to align with the web by default? So concretely, this means that over time, the React Native API surface will evolve to look and behave more like the web. You will see roughly 3 categories of changes. So for existing APIs, you will see changes in shape and behavior, so they look a little bit closer to their web counterparts, ideally as close as possible. But we will also add brand new capabilities to React Native from the web that will allow you to do things that were difficult or impossible before. Later in the talk, you will see examples of all of these changes. But before we jump into additional details, let's cover some design principles. Those of you who are familiar with React Native know that one of the most fundamental principles of React Native is matching people's expectations for each platform. This principle is not changing. React Native will still render platform UI primitives and allow you full access to the native platform APIs. Anything you can do in native, you'll continue to be able to do with React Native. But now, additionally, we want developers to share code that should be shared, saving them time for meaningful platform differentiation. We don't want developers to spend their time rewriting the same platform-agnostic code again and again. This is the inefficiency we're going after. And finally, we will align with web standards by default while still supporting platform-specific paradigms. So for example, on Android, there's a unique elevation API that produces shadow effects, but it doesn't map cleanly to web shadow APIs. Similarly, there are materials APIs on iOS and Windows that produce cool effects like frosted glass that are also not simply represented by web blur APIs. So we're not going to try to shoehorn those together or kind of map them awkwardly to each other. You'll still have access to these platform APIs through React Native. So as we move React Native in this direction, how is development going to change? Most importantly, you will see significantly more code sharing across web and native experiences. It's always been possible to share some business logic, and a lot of React and React Native apps share code in this way today. But UI code always had to be distinct. And this is something that's going to begin to change as we move toward the web standard. But aligning with the web will also further increase skill transferability between React and React Native. It's already pretty good, but still for someone coming from web who's brand new to React Native, they have to learn a lot. So what we're hoping is a reduced learning curve for those folks. And for people who frequently move between React and React Native development, we hope to see increased development experience consistency. For example, today, React Native offers the Flexbox API. It should be so convenient. You would think that it would work just the same way as it does in the web, except for most of the defaults and also some of the behaviors. Our goal is to reduce these differences as much as possible so developers don't have to remember how to work around them, and we don't have to have these kinds of warnings in our documentation. So I've been talking about this direction as if it were theoretical, but actually, we've already begun some of this work. During the keynote earlier today, you heard about an experience called Account Center, which is a product used to manage your linked Instagram, Facebook, and Horizon accounts. Something that distinguishes Account Center from the Meta Quest store is that its UI code is actually largely shared. It's one code base, one theme, and it ships to web and VR. And there are no web views here. This is React in the web, React Native, and VR. Of course, the code is not 100% the same, but that is not our goal. There should always be some bespoke code to enable platform-specific differentiation in capabilities. But we have gotten a lot closer with Account Center, and we've observed just a massive productivity boost for engineers. Now, to detail some of the specific work that has made this possible, here's my colleague, Naman Goyal. All right.
All right. So do you like the new vision for React Native? All right. So the vision is nice. Let's see what we're actually doing to make it happen. And for that, there's a classic stack of layers. This is a typical React Native app. And for the longest time, you can already share your code base across many different platforms when you're using React Native. But when you add web to the matrix, you see that there's a major difference. The truth is that since the beginning, web and React Native code bases have had to be separate. They have had to have pretty major differences. You use different primitives, you use different styling systems, lots of little changes. And over time, as the web has evolved and gained new features, the difference between them, like they've drifted apart even further. And we want to bring them all back together. And to do that, we're working on every single layer of the stack. And so the first thing is like the React Native core. That's where everything begins. So let's see what that is about. To oversimplify, and I really mean that, we can think of React Native core as 3 different parts. And the lowest part of that can be called the renderer. The renderer is responsible for rendering the platform-specific views, so UIKit or Android View widgets. And it's not really changing. Like the way the renderer works will remain the same. We are continuing to render platform-specific views on each platform. We're not going to start rendering web views. But when we move up one level, the way we use these views, the way the React Native core exposes the capabilities of these views will feel much more like the DOM going forward. So when you use a ref on the web, you're used to using a bunch of features on it. And many of these features are now coming to the React Native as well. Focus, children, DOM APIs, all of that. But even more powerful features such as intersection observer and resize observer are coming to React Native as well. There's many more, but I only have time for highlights. So let's move on to Yoga, the layout and styling layer for React Native. You may know that we shipped support for gap in Flexbox not too long ago. And just like most properties in React Native, it supports number values for lengths. But we are actually expanding what can be supported in properties. Work is going on to support new kinds of units. So you can use numbers, but also numbers with units on React Native. And you might be like, but pixels is just numbers. Why are we doing this work? Because we're not just talking about pixels. We're going to add more units, VH, VW. And not just length units, we're also adding support for percentages. And percentages isn't just going to be for gap. Anything that should support percentages will get it. So border radius will get percentages too. And and all of this work is leading up to supporting much more powerful features like calc in the future. So let's hope we get there soon. And outside of these features, there's other properties. Position static is coming to React Native. So you will finally be able to absolutely position an element, not just to the direct parent. Missing features are being added, space evenly, and we're fixing many, many, many bugs. So that's the React Native core. Let's look at the next layer, which is React. Now, React has already been the same between React Native and React on the web, but it's worth calling out that the way it worked was not always the same. Let's look at this example. And more specifically, let's focus right here, the use layout effect. If you're used to using use layout effect on the web, you know that it runs synchronously on an update, which means before the browser paints, the use layout effect runs, and you can make some last-minute changes so that you can do layout calculations so there's no jank. This is why it exists separately from use effect. But traditionally in React Native, this was still asynchronous because there was an asynchronous bridge between the native layer and the JavaScript layer. With all of the improvements, with the new architecture and all of the improvements to React Native Core, this will now just work. And that's React. I could give you more examples, but there's no real change there. But even with all of these changes, we haven't quite achieved the vision that we want. Like, making all of these improvements to React Native in a backwards compatible way so we don't break everyone's apps is a challenging process and not going to happen overnight. So we actually added a whole new layer to to the stack called React Strict DOM, which accelerates our process of achieving that vision today. And let's look at what this does. And so React Native DOM is kind of like shimming all of the APIs that you're used to from the web and just bringing them to React Native. And it's built on two pillars. First, there's a unified styling model powered by StyleX. If you don't know, we open sourced StyleX back in December. It started off as an API inspired by Stylesheet from React Native. And we took it to the web, and we added all the features that you need on the web, such as media queries and pseudo classes. It turns out that the web has more constraints. We need to server render. We need more declarative APIs on the web. And now we're bringing that back to React Native. So you'll be able to use media queries and pseudo classes, and you won't have to write a whole bunch of custom JavaScript code to do that. React Native will get more responsive and more declarative by using this. On the other hand, we have a unified markup model. So divs, spans, image tags, they're coming to React Native. Now, they're not rendering web primitives. They're still going to render the native primitives behind the scenes, but you don't have to learn a whole new API to do the same UI development. And since these are going to be type safe, you will get a very early checking for anything that you might get wrong. The type checker will guide you and help you get things right. And so if you might think, like, hey, this kind of reminds me of React Native for web, that's because it's built by the same person. Nicholas Gallagher has been doing it. That's React Strict DOM. We're very excited about this. And this enables you to finally merge your two app code bases into one code base. So you see all of this. And even though you've been told multiple times, you might be thinking, hey, have we arrived at write once, run anywhere? And sorry, but no. Write once, run anywhere is a non-goal. Like, let me repeat that one more time. We are not trying to share the entire code base across all platforms. We're trying to enable more sharing so that you have more time to work on the parts that need to be different. And there will always be some parts that need to be different for different platforms. So to recap, web compatibility is React Native's new North Star. We will take inspiration, not just inspiration, we're going to take new APIs from the web and implement them in React Native in a way that makes sense. This will enable more code sharing, and we will keep implementing new features into React Native itself, but also React Strict DOM, which is our experiment to achieve that vision quickly. We've got lots of partners experimenting with React Strict DOM. Microsoft is experimenting with it and helping us with it as well. And we would love if you would also start experimenting with us with React Strict DOM, contribute, give us your feedback, and then we can make it even better. So to wrap up, here are some links. We've got React Strict DOM. We've got StyleX. There's a post talking about all the new things in yoga if you want to dive into more detail. And there's another very deep dive into all of the little intricacies about how the event model of React has changed. So go read that if you want more knowledge, and thank you.
Oh my goodness. What a shuffle, what a shuffle. That was an amazing debut. Thank you so much, Naman and Goran, for sharing that, as well as Olga. All right, cool. Can everyone please stand up? All right, cool. We're going to do the same exercise as yesterday. Say hi to your neighbor, have a conversation with them, introduce yourselves. All right, don't let this be the last opportunity. Y'all engage with each other. You know? Great. I hope that y'all exchange Twitter contacts, LinkedIn, be friends. But great. All right, awesome. Hopefully Twitters and whatnot have been changed at this point. Y'all can sit back down. That's awesome. All right, while we're settling in, we're getting to a point where it starts to feel very sad. Sad because it's starting to get very good and sharing and hearing so much about what's happening, but also sweet at the same time, seeing the amount of progress that's being done, and hopeful for how all of these announcements actually ends up happening into the community, what people find and feedback that's provided. So we're gonna go into one of the last pieces of today's conference. Our host for the Q&A is an amazing personality. He's based in Portland, and he is a 4-time ice hockey champion, which I can see why. He plays the goalie position, so he's probably very well suited to look after both the community, the spaces, and projects. So let's give a huge, warm welcome to Jamin. You have a mic?
How's everybody doing? Good conference so far? This is the last act, so hopefully we, go out in style. But we'll also not keep you too long. So I'm really excited to be able to host this React Native panel. My name is Jamin Holmgren, and yes, 4-time ice hockey champion. This is true. I won't tell you what level of league it was. Not NHL. So I'm extremely excited about this. I will give each of these amazing people a chance to introduce themselves in just a moment. So, but I'm going to go first, and I have a few notes. So, yes, I live up in Portland area. I've been doing software for about 20 years, which is crazy to say, and React Native for the past 8, I basically started doing React Native as soon as it came out. And, I live on 3 acres with 3 of my 4 kids. My oldest is now a software engineer, which is awesome. He's following in my footsteps. The only downside is he's doing Vue and Laravel. Why couldn't he just get a tattoo or something, rebel? I run a React Native consultancy called Infinite Red, and I'm also the host of the React Native radio podcast, and also organizer of Chain React Conf, which is a React Native conference. Anybody here been to Chain React Conf or going to go? Nice. Yeah, that's awesome. I'd love to see you all there. Feel free to swing, come talk to me. I have a discount code, maybe, for people at this conference. So, you can also follow me at Twitter, at Jamin Holmgren. I talk a lot about React Native. All right, so, panelists. I'm going to start with you, Kevin. And What I want you to do is introduce yourself and say what you do at Meta. And also, I want you to say something weird that you do with technology or a weird technology that you've used in the past. So for example, my website, jamin.dev, is written in QBasic. I'm not kidding. It's open source. You can go check it out. So let's start with you, Kevin. Introduce yourself and something weird.
All right. Can you hear me? Yeah? All right. I'm Kevin. I've been in Meta almost 10 years. Been in the journey of React Native since the beginning. I somehow landed in the team using React Native. I have no idea. But that was before open sourcing, so I stick around until today. So I'm an engineering manager, so supporting all the new architecture, basically all the work from Nico, Ricardo announced today. Yeah, and I still code, unfortunately. Yeah. Anyway, the weird technique, it's not really weird, but my debugging friends are print statement, console logging. I never use debugger sometimes because I don't have time for that setup. Yeah. Right? And yeah, that's me.
All right, thanks a lot, Kevin. And Nico, I'd love to have you introduce yourself, what you do at Meta, and some weird use of technology that you've done in the past.
Awesome. So, hi everyone, my name is Nicola. I'm a software engineer on the React team. And what I do is I answer to GitHub issues for React Native. No, actually, no. I do a lot of work on React Native. And yeah, so weird use of technology. Yeah, I also run a podcast. It's quite niche. It's about open source. And I started it during the pandemic, and I obviously wanted to self-host everything. So I created my own infrastructure and so on. And I used like static site generator. And now people will throw stones at me because I use Jekyll, which is written with Ruby. Don't hate me for that. But I was ignorant. Like, I was not using React before. So yeah, like I literally spent an entire year building it, and then at some point I just realized, okay, I actually need to record episodes at some point because, like, you know, nice infrastructure, but you need to have content. So yeah, that's my weird use of technology, I guess.
That's like every developer blog. It's like, hey, here's my new blog from 4 years ago.
Exactly, exactly.
No new articles. All right, thanks a lot. Olga, you're next. Introduce yourself, what you do at Meta, and some weird use of technology.
All right, my name is Olga. We just met. If you were here 20 minutes earlier. I am an engineering manager at Meta on the React team, and I've actually been at Meta for exactly 2 years. Like, this is the day when I started 2 years ago, which is really cool. And what I do is, I guess I talk a lot. I'm not sure what else, but maybe I'm making some contributions. I talk a lot about cross-platform React, React Native Desktop. If you're interested in those things, come talk to me. Weirdest use of technology, at a startup that I was at years ago, we were building these modular robots. And the robots were controlled by a real-time operating system running in an isolated core in a Windows machine. And what I was doing was building modular React UIs to talk to this real-time operating system to give you the ability to control this robot. So we had like a WebSocket streaming state back and forth. It was really great, but it was React, and it was for the first time we created like actually beautiful UIs for controlling these things. If you look at actual usual industrial UIs, they're not good.
That's awesome. Thanks, Olga. And last but not least, Ricardo, please introduce yourself, what you do at Meta, and some weird use of technology.
Hi, everyone. I'm Ricardo. I'm a software engineer in the React team at Meta. I work closely with Nicola. We reply to all your questions on GitHub. My background is on iOS engineering, so if your iOS app is building, it's probably because of some of my work, even if it's failing, but like, let's not go there now. Okay, weirdest technology I used in the past. I am a mobile engineer. My first mobile device was a Symbian, and I had to write C++ code to make it communicate with a controller for a wheelchair over Bluetooth.
That's awesome. Thank
Crazy
you all.
stuff.
I appreciate it. So we don't have a lot of time, so I'm going to get right into the questions here. The first one is regarding the new architecture, and you may have heard about this before. Some of you may not totally know, but in short, the new architecture for React Native is a rewrite so that it brings React Native into the React 19 era. It enables all these new features that you've been learning about this whole conference. So, Ricardo, I'm going to put you on the spot. How is that new architecture rollout going? Is it going according to plan? And when do you expect the new architecture to be stable?
Okay. Easy question to start, okay? Perfect. Well, as you know from the keynote this morning, the rollout is proceeding pretty well. We put it officially in beta today. What does it mean for it to be in beta? It's because we want you to try it. We think it's stable enough for you to try it out in your application, but it is still a beta. So expect some rough edges, something that we need to make perfect or make it more stable. We need your help for that, so that's why we are asking you to try it out and report issues. When do we expect a stable version? We hope for by the end of the year, this year, but life can happen, so that's the expectation.
I appreciate you putting a date out there, even if it's just an estimate. That's okay. All right, Kevin, I've got one for you. So you've been around a while. I'm not calling you old. I'm just saying you've been around a while. You've been around for basically most of React Native's, is it all of React Native's history?
Almost.
Almost all of it. So first off, I want you to maybe give a little bit of history of React Native itself. Can you give us a little insight? Well, actually, here's the question. When you were first shown React Native, did you think it was just wild, like this could never work, or did you immediately see the possibilities?
Yeah, funny story. So I was an iOS engineer before joining Meta. We had this bootcamp, so my mentor gave me a task. It says React and CSS. I'm like, okay, I guess that's a warm up. I open the task and then start working on it, and the instruction says install an iOS simulator. I'm like, what? What is going on here? And then that's React Native, and I thought, actually, this is pretty cool. Before that, I read the React website, and I thought it was weird. Sorry, I'm not a web dev. But learning React from the native point of view from iOS actually is super easy. I was like, oh, yeah, okay, makes sense, view and text. So, yeah, that's my take.
That's awesome. So recently, the RFC for React Native Frameworks was released, and it was talked about earlier in this conference. So, Nico, obviously it's Expo at this point, but obviously this is sort of laying the groundwork for other frameworks as well. How do you see the React team's relationship with Expo and potentially others evolving over the coming years?
Yeah, that's a great question. I wanted to mention how, this morning I was there at the podium and we just mentioned, you should use Expo. It was 2 minutes announcement. But those 2 minutes are the result of 1 year plus of work. Literally, we had recurrent meeting with folks at Expo, ColdStack, Microsoft. We spoke with the community. We asked opinions because we just don't wake up one day in the morning and call out hey, yeah, you should use this tool and so on. We literally did a huge amount of work with our partners because we really believe that we wanted to steer the community in the right direction. So this is, I think, a breakthrough for React Native. I remember last year, Eli, which is somewhere in the audience, there, he asked me and other folks also, what do you feel is the right move to 10x the React Native adoption? And I feel, and a lot of other folks that I talk with also feel the same, that moving towards this model where we have React Native core and framework layer on top is the best way to be competitive in the cross-platform market. Because it's not just React Native out there, right? There is Flutter, there are other solutions, and we want to offer the best tooling for our users.
Yeah, that makes a lot of sense. And Olga, you just talked a little bit about how we have we have convergence, really, between React.js Web and React Native with, of course, React Server components. Evan showed that on React Native, and that's going to be on Web as well. React Strict DOM, React Native DOM now. So as a React Native developer myself, do you see React Native being continuing to be like a distinct thing, or do you see them converging into one thing eventually? And where, if it's going to be distinct, where will it be distinct?
Yeah, it's a great question. I think what we're looking to do really is just narrow the gap between React and React Native. And in a lot of ways today, the gap is not like a well thought through plan of differences that make sense. It's a lot of things that kind of happen incidentally, or maybe where React Native needs to catch up a little bit. So those are the things we're working on eliminating. We're never going to get to the point where we just have one framework and it ships everywhere, and you have like this single code base that ships everywhere. There's always going to be room for platform-specific expertise and like that, maybe the last 10% of platform-specific polish that requires kind of native expertise. So you're never going to get to the 100% shared code, but like except in maybe simple cases. But really, to create truly like native feeling experiences, you're always going to need to do something different for React Native versus React.
I'm glad you said that, because now I still have a business for a while.
You're welcome.
Don't make me do web again. I'm sorry. Was that out loud? So one of the questions that I have gotten actually from some of you out there, and I'm sorry for those of you on this side, I'm really not trying to exclude you. This thing was not easy to move really quickly here, so. But I guess you can see us up there. One of the questions that I will get often from non-React Native developers, and even React web developers will ask me this, I've been asked this at this conference, is will React Native kind of keep thriving, or is it going to eventually, like, are these companies going to kind of lose interest in it, and will it just disappear? And I know from my own standpoint, I've been a part of technologies that have kind of flattened out. I used to be a Ruby on Rails developer. I enjoyed it, but it sort of flattened out and maybe isn't thriving quite as much as it used to. So I would love to have maybe a few of you answer this question. I'm going to start with Kevin. First off, like from your perspective, do you see React Native continuing to thrive, especially at Meta, and in what ways is Meta investing in React Native internally?
Yeah, so as Nico shared today from the keynote, there are thousands of screens, surfaces. Those are individual surfaces within Meta products. Facebook, I've had 1,000 plus. I'm kind of responsible as well, like trying to make sure they're fine there. So there's a lot of use case, and the org grows, and use cases continue. So I don't think it's slowing down. It's actually growing. So yeah, from Meta point of view, I think it's going to continue. So Olga, you want to add something?
Yeah. So I actually get this question from some of my friends too. Sometimes like, oh, is React Native, is that still a thing? Like, should I develop with that or Flutter or whatever? And I'm always a little surprised to get that question, because I think internally, maybe we don't talk about this enough, but it just doesn't feel that way at all being at Meta. Our team is bigger than it's ever been. The number of developers at Meta using React Native is bigger than it's ever been, and it's growing. And the number of partners like a lot of what I do every day is talk to new partners at Meta. The number of those folks is growing as well. So I think Meta's investment in React Native is only going to continue to increase, and that's even over my past 2 years here, I've observed that.
Yeah, that's awesome. And even as we've seen in this conference, a fairly big chunk of it was React Native, and not just from Meta. There were, Amazon, for example, gave a great presentation about this. And I look at Microsoft's investment as well as being a good signal for the health of the community and all of that. Ricardo, I have a question for you. So if anybody in the community who's using React Native, and if they have ideas or improvements for React Native, what is sort of like the best way to get started down that route?
Okay. So I guess that we can divide the ideas and contribution into buckets. like small contribution and bug fixes, things that are issues that are open, you can just submit a PR for that, and one of our engineers will jump on the PR and help you shape it in the best way and make sure that we can land it. If there are bigger contributions, like new features, stuff like that, the best thing to start is probably to either reach out to one of the meta engineers and start discussing about that. Like, for example, in this conference, I had the chance to talk with a lot of you and like collect some ideas. And the next step is usually to open up RFC on the proposal and discussion GitHub repository, where we can start talking about that. This is the first step. Meta engineer will jump on that RFC. We're going to share our comments, our concern, help you shape it in the best way, and create a plan to make it happen, which is also something that we did together for the White Gamut display P3 support, which is progressing.
Yeah, that's great. And I can definitely say firsthand that the React team, React Native team, they're very, very willing to help when there's an improvement that makes sense to do. So definitely reach out. Don't just submit a PR, like a giant PR, and be like, hey, merge, please. You know,
that's the worst thing to do.
Yeah, there's no context. There's, you know, it's a very. I mean, there's a lot of people using this. So, this question is for really any of you. I'm going to ask Nico first, though. So I counted up the number of languages that if you were to touch almost every aspect of React Native, the number of languages I think is 10.
I think it's more than 10.
Is it more than 10?
I think yes, yeah.
Do you mind if I try to list them all? Okay.
Let's list
so,
them all.
JavaScript, TypeScript, Flow, because obviously internal, right? And then you have Objective-C, Java, Swift, Kotlin. You have Ruby in the build tooling. You have Groovy. Do you all know what Groovy is? Yeah, some of you know what Groovy is. All right.
Sadly, yes.
C++.
Yeah, obviously. There are some files in assembly.
In assembly?
Yeah. What else do we have? I think, well, Bash scripts.
Bash scripts? Okay. Yeah, I was way off.
Windows batch files.
Yeah. In Windows.
Yeah.
Oh, yeah, C# too. If you're doing React Native Windows. Not core, but yeah. Anyway. Okay, so that leads into my question. So the skills that are needed to work on the different aspects of React Native are understandably quite vast. So how do you keep up with all of these different languages and APIs and platforms?
It is really a challenge, I have to mention. And that's also one of the reasons why we put a lot of care in what we ship in React Native releases. And really, we try to reduce the number of breaking changes as much as possible. But I feel we are not yet at the quality level we would love to be. So there is space for improvements. Like, for example, over the last year, we started rolling out tools that helps us inspect if the API changes on Android or in C++ or on iOS are changing. Because sometimes, like, you add a new feature and it touches, as you said, like 4 different programming languages. And then you need an expert in every field to tell you if that change would actually be a breaking change or a behavioral breaking change on a given platform. So catching those changes like automatically is extremely hard because of the nature of mobile development. So we are like doing a lot of work, as I was saying before, like during the keynote, on like how more focused we are on making releases that are like less breaking and so on. Like we are in the right direction. Obviously, again, there is space for improvement there, but yeah, it is a challenge.
Ricardo, do you have anything to say on that one?
I mean, to answer to the portion of how do we keep up, luckily we are a team. We have several people, different experts, as Nico was mentioning. So if I had to touch something on Android, I may put up some changes, and then I go to Nico and ask him, like, does this make sense? Or, like, I did something wrong? And same stuff, if he has to do something changes on iOS, usually comes to me and can review this code. So we try to leverage each other as a team and every like strength of the people that we work with to make sure that what we push to both internal and the open source side of things is the right thing to do.
So I'm going to give you a little bit easier question, hopefully. This is for everyone. What do you think has improved the most about React Native in the last year? And then what would you like to see improved in the coming year?
I guess I can go.
All right.
Oh, you want to go? Yeah. Yeah, I mean, I'm biased. I really see React Native from the open source perspective as much as possible. And I feel personally that the release quality has improved a lot. Like, upgrading React Native version is easier, at least just by looking at the diff of the upgrade helper if you don't use Expo. And generally, like, I personally also feel that the way how we respond to the community has improved quite a lot. Like in the past, you probably opened like GitHub issue, and you even spent time like creating reproducer and explaining us why things were not working in a certain way, and then maybe you got ghosted. And no one answered you, and then, yeah, like your effort went in the void. Well, trust me, the amount of issues that we receive daily is still significant, but I feel that we personally, like, we are doing a better job in understanding the signal-to-noise ratio, no? In how the community is telling us if things are working well or not. So, for example, we look at the React Native subreddit more frequently. We looked at issues reported on Twitter more frequently. We looked at all the issue reports on GitHub, and we try to tell you, like, okay, we can fix it like in the immediate future, or like, no, we don't have capacity now, your bug is important, we will get over it as soon as possible. So I think that really the relationship that the React Native team has with the rest of the community has improved, but you folks should tell me, like, that's my side of the story, obviously.
I would agree, just from my perspective, absolutely. Any other responses to that question? Just to read it again, what has, in your opinion, has improved the most about React Native in the last year, and what are you looking forward to, improving in the next year?
Yeah, I'm gonna give some perspective, not from the technical side, but in terms of expertise. We started with a small team, trying to like rebuild the whole new architecture and stuff. We learned a lot. We actually spent time learning C++ from the scratch, from zero. I mean, that's how we learn. I mean, we're not expert really, but we help each other. And then I think over time we grow number of people, and then we have to keep shipping. We have to keep building and keep rolling out and stuff. And then how do you keep up with that learning curve while growing the team and making sure like when life happens, things continue to ship. So I think we got a lot better.
Okay, I didn't realize, but the time is going very quickly. So I'm going to skip a few questions, and I asked people around the conference for some spicier questions, just to make you sweat a little bit, all right? So they may or may not have been on some of the questions I provided to you beforehand. Okay, so why doesn't Instagram use React Native?
You're talking about Instagram, right? Yeah, okay. So for the record, Instagram web use React, so that's fine. The mobile app actually use React Native. There are some part of it, I'm not fully aware like which part, but like there are some usage. But at Meta, we don't really force people to use the technology, right? I think we really need to see like what's the use case and what is the expertise that the organization have. So for example, if an organization already have like a full iOS, Android dev, like does it make sense to force them to use non-Android, non-iOS? Probably not. So I think it's more about like how you leverage that expertise for the need at a time. So I mean, I can't really say why the usage is limited, but it all depends. It's not like we're trying to take over the world for something.
Yeah. So this one's not quite so spicy, but I am curious about this one as well. What do you see the role of React Native Web being? And I know there's some overlap with some of the things in the past, but I really want to hear this one.
Yeah, I mean, I think first of all, React Native Web continues to play a really important role and will continue to play a really important role, but what I think something that I see changing as we move the React Native API closer to the web is the amount of work that React Native Web has to do is going to really, really shrink. So ideally, React Native Web can be a really, really thin layer. And if you want to, in the future, write your code using the React Native API and ship it to the web, you'll be able to do that, but you will not have as many downsides in terms of performance, because the React Native Web would just be a really thin layer on top of React Native. But I think it really is going to probably serve a complementary role to RSD, where you'll be able to kind of use whichever API you want and still be able to get the functionality you want on React Native and React.
Okay, last question. When are we going to see version 1.0?
I was waiting for this one, man. Yeah, I mean, what's the next question?
I'm sorry, I'm out. I have no more.
Okay, well, we are discussing about versioning, as you can imagine. What I was telling you before is that, I mean, we are really committed to what we ship. And we want to ship versions that are stable, and we want you to trust us that we're not going to break those APIs and those behaviors. We had a number of discussions in the past of like, React Native is stable. Like, people are shipping like huge apps with it. Why are we calling it a 0x? And imagine also from like a CTO point of view, like people, do you want to trust a technology that is released as 0 dot something? So yeah, like we had a number of conversations in this space. But as I said before, I think there is space for us to improve. There are a number of steps that I believe we should still take till we will see React Native 1.0. And that means like more stable API, like being like we want to demonstrate to the React Native community that we can go 1 year plus without breaking changes, and that will be the moment when we are actually like ready to ship a 1.0.
Yeah, that's a great answer. And I'm going to drag my meme out that I tweeted the other day and retweet that again. It shows a guy looking in anticipation, and it says React Native 0.99, and then the next panel says React Native 0.100.
That would be awesome.
Well, thank you all for being part of the panel. Let's give them a big hand of applause.
Mic check. All right, awesome. Well, 2 days of jam-packed with information, releases, demos. We're finally here. So let's give a huge round of applause. We made it through ReactConf 2024. Woo. Yeah. I want to reiterate Eli's thank you earlier. Thank you so much to the sponsors, the AV team, the speakers. There's a lot that goes into making this happen. I want to say a huge thank you to folks like Seth again, Matt. Like, this would all be possible without their contribution. So let's give them another huge round of applause and some love for making this happen. Now, I don't have anything else to say, but another heartfelt thank you for myself personally. Y'all allowed me to come out here and share my vibes, share a little bit about my culture, and y'all accepted it with open arms and a smile. So really deeply, truly, thank you. It's been an honor being your vibe officer. Thank you. Okay. So, I do not know when we will meet each other again. However, hopefully at the next meetup, at the next conference. So as we end and you guys go back home, take the words and the history and the vibes with you, share with one another, spread that kindness, that love, that excitement and appreciation for React. Share everything with the world and keep doing amazing work. So thank you. This is the end of the conference. I'll see y'all next time. Thank you. Woo! Woo! I have one last thing. Meta team, leadership team, call stack. Where's the call stack? Where's your slope? Can you please hold and come to the front, please? We're gonna wrap up and take a photo, group photo, leadership photo. All right, man, appreciate it. Thank you so much. Finally here. Right, it was. Yeah. Brianne.